Yeah, I'm not sure if Blanche and Quartz are going to join. But if they aren't, then we can go some things again, but I think we can just get started. I would just kind of go over some of the like more basics, like kind of the overview, and then maybe like just build a note or two. If you have any suggestions for that, just let me know what notes you want, because I haven't planned any specific note that I could build. So yeah, just let me know if there's any like specific note that you want to see in Serpens, because then I would just build that. Yeah. Maybe I should see the chat notifications. So yeah, let's get into it. All right, so packages. So basically, we built Serpens in a way to allow anyone to build custom nodes. So everything complicated, or at least like more complicated, is hidden enough to where it should be fairly easy to build a node. So yeah, and packages are just kind of our way to allow any developer to build their own node, to kind of package some Python code into a usable Serpens node for other users to to play with. So we have some documentation on all of this on our docs. Kind of the most interesting part is in here, where we kind of go over everything here, like all the different attributes. There are actually some more that you can find in the code, but these are kind of the most important ones. But let's start from the beginning. So the way you would develop a package is kind of different from today, like to how it was before. Because actually Corsair posted that he installed the new update of Serpens and lost his notes because he didn't like save them anywhere else, which is a bit annoying. So the way I decided to kind of fix that, hopefully, is to basically write a script that allows you to develop your nodes somewhere else, and they're still getting included in Serpens. So this is kind of laid out here. Anyone else can hear? Can you? Yes. Okay, perfect. All right, yeah. So I wrote a script which you can use to develop your nodes somewhere else while still keeping your Serpens install separately. And I will just quickly go over that. So basically, you get this file which you can download it right here. And the way you use it is that you kind of you create your package, so just like your folder with your node files in them, which we'll go over. And then you place this Python file just in the root of your package, and from there on, this, like, you don't need to care about any of this. This should just kind of work for you. Hopefully, again, I wrote this today, so we'll see. But you basically just specify the root folder to your Serpens install. So if you go into your Blender install, the version, and then in the scripts, add-ons, and then in here, just copy this path and paste it in here. And then that's all you need to do in this file. Here's also a quick way, like introduction on how to use it. But basically what you want to do is open some terminal. It doesn't have to be in VS Code or anything, it can just be like a separate terminal. And then you want to run this file. So I will just run python dev.py, and this will show you that it's installing the package, that the package was installed successfully, and that it's waiting for file changes. So what you can do from here is, first of all, restart Blender. just because like every time you change the nodes, you need to restart Blender to actually see the changes, and then you should like be able to see your nodes here. So what this is doing is it's moving everything in this folder apart from the dev.py file and the package info file into the nodes folder, which is where you would develop your add-on before. So you would just like create new Python files in here. Now you can create Python files somewhere else, and this will automatically transfer them into the node folder. And the kind of interesting part here is that if I go into one of these files, there's nothing really in here, but just for a demonstration, like if I just put a comment in here and save this, you see the file that's running here, the script that's running in the background, notices this file change and updates the node. So if I go in here under this something folder, which is the one I have in here, and I go into my node and just open this here, you can see this was updated. So if I go in here and remove this comment again and I save, you can see it updates and it's also getting removed from this other file. So you still need to restart Blender to actually like refresh your nodes, but you can now develop your package somewhere else, like entirely, and you can also use Git to kind of keep track of these changes. So you can like create your own repository, push all of this, and like keep a changelog of what you're developing, and at the same time like be integrated with Serpens. And the same also goes for like creating new files. So if I just copy this file, you will see it's tracking the new file and copy that to there. And if I remove a file, that works as well. So it keeps track of these removed files as well. Yeah, and that's kind of how you use this this dev.py to develop your add-ons. Sorry, your packages. And when you're done with like finishing a version of that package, I just added one more utility to this. So if I just write -- build behind this Python dev.py, then it will build your package. So it will just create the zip folder with all these files apart from the dev.py in here, and you can just share this with others. So it's just a bit of a quicker way to package this up now. Yeah, any questions on that?
Wow, that's awesome.
Yeah, I think it should be a bit of a better way than what we have right now, which is nothing.
Yeah, which is go open up the nodes and try to duplicate what you see.
Yeah, you can definitely still do that. Like it's still useful to go into the nodes and so on to just to check on other things, like how they work. But I think this is a bit nicer, especially for like using Git. I would really recommend just like initializing a repository in here and just pushing your changes once in a while, so you can keep track of your code and keep that separate from the rest of Serpens. Yeah. I mean, I can go over this if you want to, like over the code in here, but it's not really relevant for the packages. It's actually
all you have to do is you just need to. Where is dev.py right now? You have to download it.
Yeah, it's I just put it on in the docs here.
Oh, in the docs. Oh, sweet. Okay.
Yeah, so you can just download it from here, create your pack, like just a folder for developing your package, and then just place it in the root. Yeah, so that's all you need to do, and then just run it from the console with Python dev.py, and it will start tracking your changes that you make and updating those inside of Serpens.
Now, if I were to close Visual Studio and reopen Visual Studio, do I need to run dev.py every time I open it?
Yeah, you basically need to run it like when you're developing, like while you're developing. So
okay,
it tracks those changes and updates the files. Yeah. Yeah, and it also won't be like installed as a package. So like while you're developing, the nodes will just be in there as normal nodes and like not show up under extensions here under the packages. Like it won't show up as a package. They will just show up as just as the nodes here.
Yes,
So
that's
that's why
correct.
that's why you just get that command for building the package, and then that will include the package info, which you then you can install the zip as a package for other users. Yeah.
Did you already cover the package info.json and the like the folder structure in general with the
No,
users?
I think I go over that now a bit. Yeah. So basically what you're doing when you're developing a package is you're developing something that will get kind of pasted into this nodes folder here. So all of our nodes are nested inside of this nodes folder, and they all go into their categories. So the way we decide on those categories that you see in the add menu here is just by the folder structure. There's no other setup for this. So if I go into debug, you can see the print and the trigger node, which is also in here under print and trigger. So for creating your package, you also want to basically set up your your package in the same way. So if I create a folder called something in here, the category inside of Serpens will be called something. There's nothing showing up here because the node files are empty. But you just create the folders you want to have as categories, and then create the Python files for those nodes in those folders. And actually with the next update, it's in my beta version now, but not in the release right now, I just added subcategories. So for example, for the input category here, you can see there's blend data, and geometry in here, nested in the input menu. Or for interface, there's layouts and sub-layouts, and so on. So it's just not one massive list here anymore, but it's getting nested. And this works exactly the same way. So you would just create a new folder in here, and that would create a category called something, and then in that category create a category called new folder. And you can create your node Python files in here.
Oh man, that's so cool. Oh, subcategories, that's awesome.
Yeah.
That'll help
Yeah,
us
it's
because
good.
Corza and I were debating how are we going to handle um, all the new nodes that are getting created.
Yeah.
I know it's just a few of us. I think it's 4 users total right now who are making new nodes.
Mm.
But we're trying to do overarching themes, and if you have sub menus, that makes it easier for us to figure out where to put things.
Yeah, I mean, in theory, we could create another category down here for packages, and move all packages that you install in there. But I think at least for now, we can kind of give the control to the package developers to put them in a place where it makes sense. Yeah, they might be a bit hidden. If you install a package and it's not clearly communicated what nodes are in that package, then some nodes might get lost. So make
Well,
sure to
yeah, I
do that,
think
I guess.
my brain's going to I would do. I've got a node that's the on key press toggle node, or I guess key map toggle node. So it's an execute function node. So I would definitely put it in program as the first thing, and then I would probably just do another folder that I call extras, and then
Makes sense.
or yeah, just program the next res, and then it would go inside of that.
Yeah.
And then everybody would know that, yeah, this is part of the downloaded packages.
Yep. Yeah. So one more thing that's important, especially with this new script here, is that you will have to create init files while you're developing. So this basically just means create a file that's called __init__.py in every empty or in every folder that you make apart from this main one here. So in this folder you need an init file, and in this one as well. If you would have node files in here, basically what that does is just tell Python that this is a folder that it should keep track of. It tells it that it's a module, which just means there's scripts in here for you to use. And because you're creating new categories, new categories that don't exist yet, you need to create those init files. If you put your nodes into a category that already exists, so meaning you also create a folder called program, for example, then you don't need to create that init file. You still can, it doesn't hurt anything. It's just like it's already in here. But if you create a totally new folder, then you want to create that just an empty file called init.py. Yeah, just for Python to keep track of it. Yeah, and then the last thing you need to do to actually tell Serpens that this is a package is to create this package info file. So what goes in here is basically just some general information on what the package is. And this will show up in the add-on preferences. So if I go into here and then under the marketplace and load the packages, it will show the name here, the description, the author and the price. And kind of all of this is in here. I'm not actually sure about the price, if that's a separate one. Package info, it's not in here. How do you actually define the price? This is your package, and you should. I'm not sure like what the name for this is.
Oh, interesting. I didn't know that the price associated was part of that package info.
I don't know. Maybe it isn't. Maybe we just save free here. Which would be interesting. Let me actually just find that out.
So Korza's here. Korza, you joined a little bit late. The only thing you missed is Joshua made a really cool tool that lets you hot dev, and as you save your scripts, it throws everything into the nodes folder on your Blender file.
Oh, yeah.
And it's in the help docs. The dev.py program is already there. You just have to run it in the Python console on Visual Scripting to get it started.
Yeah.
Are you recording this, Blanche?
I am.
Yeah, sweet.
Yeah, I'll post it. Now, Joshua, your screen is a little bit pixelated for me. I don't know about everybody else.
I'm also recording my screen so I can.
Oh, okay, perfect. Joshua's recording will be much better than ours. Yeah, that'll be great.
Yeah, but I basically, just to like very quickly repeat, I basically made it for like after seeing your message about losing your nodes when installing a new version, because like really when you develop you should have your nodes in a separate place, and that wasn't really possible.
Yeah.
And then like keep track of your changes with Git. Yeah, so what you can do now is just place this file here, enter your Serpens install path, and then just run python dev.py, and this will keep track of all the changes you make to any files in here. So if you save a change, it will update that file in the Serpens install. So in the nodes folder, it will just copy everything in here, and you just restart Blender, and then it shows those changes. Same for adding new files in here and removing files. Yeah, and that's basically what this file does. In addition to the build command, which just zips up your package that you create here.
Yeah, that's so cool. You can makes your whole package for you with the -- build command.
Oh, I was wondering what was happening with that, because I tried adding some new nodes yesterday, and it was just breaking everything. This sounds cool. I like the idea behind this.
Yeah, like it's a first implementation. I just like spent an hour on it this like earlier today. But like yeah, so let me know if anything breaks or if you have any changes you want to make to that. Yeah. Okay, but
yeah, continue on with what you're doing. Like I'll catch up. I'll just rewatch the videos and that.
Yeah. Yeah, so basically when you've created your kind of package structure, meaning a main folder with the subfolders for the categories that you want to show in here, and then the Python files for the individual nodes, then you can, and the package info, then you can take those folders and put them in a zip file. So you can find this on the delivery here. So basically the final package will just be that zip file with the package info, and then the category or more categories in here, and now also nested categories. Yeah, and then you can share that zip file. You can use the bot in here to upload it to the marketplace, and other users can just simply install it by going to extensions, packages, install package, and then just selecting that zip file, resetting Blender, and then those nodes will show up in here. Yeah. Okay. Yeah, so I think that's basically all the setup stuff you need to have for packages. It's like really not that much to kind of get into it, because the main part should be about the nodes. So I hope like that's the rest is fairly easy. This part will probably like take a bit to get used to kind of how we have our structure. So yeah, we'll spend a while on that and build some nodes. Again, like let me know if you have suggestions for nodes. I don't have any plans on what specifically to build. So yeah, just let me know. But yeah, I'll just like quickly go over what we have in here, just maybe on an example. So if I just go into like, let's say the program and then operations and if else, because that's kind of one of the simpler nodes, you see that like all we have in here is one class, and we're not registering it. This like all happens automatically in the background. It's just you define one class, you pass it the bpytypes.node, so the basic node class, and then the scripting base node, which you import from the base node file. Just like we're just using relative imports here, and that's just in here, so in the nodes folder directly. So depending on like what level your node file is in, you want to yeah, change the import here. Yeah, so you just pass those two things, and that will kind of define your node. And then you want to define the ID name, which can just be the same thing as the class name here. And this should probably start with sn underscore. It doesn't technically have to, it's just like a convention, so we don't overwrite any other add-ons and so on. So every panel operator and so on that we use starts with sn. So you can also use that for your nodes. Yeah, and then
that's an acronym for Serpens Nodes, isn't that right?
Yeah, it actually started when it was just called scripting nodes when we didn't have a name. So SN is technically scripting nodes, but it also works for Serpens nodes. So yeah. And
what does SNA stand for?
Just scripting nodes add-on. It's
okay.
Yeah,
Scripting nodes add-on. That's right.
I spent like 3 seconds coming up with with that acronym for when I needed it for the first time. So yeah. When you have two nodes with the same name, it will just like use the last one that happens to get registered. So it's probably just like the order the files get read in, and the last one will win. Or maybe actually the first one will win because the second one will fail to register. Like one of them will fail. Just yeah, try to pick unique names, I guess. You can also like use a different abbreviation here if you just want to be certain, but like if you use a name that's fairly unique, that shouldn't be a problem. Yeah, and then you define the BL label with just the label that you want to show up at the top of your node and in the menus. You can define the width, so you don't need to, but you can define the width. I think the default is 150. And all the defaults you can just look in the base node file, which is like, it's pretty long because it's one of the main like places where things actually happen. But you can like just look kind of at the top here to see some of the defaults. So the width default, you can also set a min and a max. I don't know if it's screen dependent. I think it's just pixels, but I don't know at which scale. I'm assuming like just 100%. Not sure, but I think this is just the default we use for most nodes. 200 is what we use for some of the ones with like more inputs, and the ones that kind of define a breaking point, sort of like the if node splits into multiple directions, so it's a bit wider just to show that break. Yeah. We don't really use icons like we used to with an older version, but we don't really anymore because they're kind of annoying to update. Like it's very easy to just move a node to a different folder, but it's annoying to match the icon for different categories and so on, so it's not really that useful. Yeah, and the other thing you probably want to set is the color. So we just have some defaults defined here. You can actually also set this to a tuple. So just like, yeah, tuple with 3 values if you want to define a color. But we just have some defaults for the different categories we have. So just put that string in here. Assign a number of sockets. Yeah, so for those, I'll go over the sockets in a second. Yeah, and then the other like attributes you have in here are the version, which you can use. We're not really using it, but basically like when you have a node and then you change how that node looks, meaning you change like what inputs it has, for example, like breaking changes to that node, basically, you could just update that version. So instead of setting the default to 0, you would like up it to 1, 2, and so on. And then inside your evaluate functions and so on, you can check what version the node currently has and then run different things depending on that. We mostly just use checks. Like if we add an input to a node, we just check if that input exists. We don't really use the version right now, but yeah, you have the option. And then the kind of final important, or one of the final important attributes here is the is trigger, which you want to set for nodes that start a node tree. So things like the panel, the menu, pie menu, trigger, yeah, trigger is kind of a fitting name, I guess. You want to define is trigger, so you want to set is trigger to true. So if I just go into like the panel node, you can see that we set is trigger to true in here. And for any other node, you just don't need to set it because the default is false. But what this tells Serpens is just to treat this as the beginning of a node tree. So I can just quickly go into how like the compile step actually works, because it's kind of like it's you don't really need to know it, but it's helpful to know, I guess, for like when you're actually writing nodes. So the way kind of Serpens works, it's good to see with the debug options on. If I just go to this label here, you can see the main code is generated on this node here. And then in the case of layout, it's passed on through the layout socket itself. So if I go to the panel, you can see the code from the label going in here in the draw function. So what this kind of means is that any code you write, or any node that generates code, passes that code onto the previous nodes until it ends up at a trigger node. And then what the trigger node does is basically probably like register it, like depending on what the node is, but generally it's just registering that node. So in the case of the panel, if I turn on debug nodes again, you can see you don't only have the code, you also have the code register and code unregister. So this is separate code that gets generated for this panel node, and especially because this is a trigger node. And Serpens handles these trigger nodes differently, because when one of these nodes change, like when the code of one of these nodes change, nothing should happen. Like the add-on shouldn't be recompiled. It should only be recompiled when one of the trigger nodes gets updated. So if I change the separator, like the value here to like 2, then this will trigger a change in this node, which will pass its code onto the button, onto this label, and onto the panel node. And only when that panel node's code changes, then it will recompile the add-on. So this is kind of a way we keep the compile, like the amount of times the add-on gets recompiled to a minimum. Yeah, so this is kind of how our auto-compile and the compiler in general works. Yeah, and for the sockets, it's kind of the opposite. For the data sockets, it's the opposite direction that is for the program sockets. So program is the interface sockets and the execute sockets. So these pass the code backwards in the tree until they reach a trigger node, and the data sockets. So if I add like a just a float node here and just plug it into the factor, when I change this value, it will pass it onto the right. So instead of going to the left like the program sockets do, it goes in the right direction. So it will pass an update to the separator node with this code change, which will update its code, and when that node's code updates, it will pass it on to this button through the program socket here. So this is like, again, just the way like these steps happen. If there's only changes in these data nodes, like if you have a bunch of data nodes chained here and nothing really changes with the code itself, like you check some option which doesn't actually change the code for whatever reason, then we don't need to trigger a compile step. We only need to trigger that compile when code of the panel actually changes. So we just pass that value to the through the data sockets and then back through the program sockets, and it will only pass on the changes when the code changes. Yeah, so that's kind of all you need to know about the compiler. And it's useful to use the debug options here, because you can actually see like what's working, what's not working. Yeah, but generally you don't have to care about this really. Like you don't have to know that this happens. It's just good to know when stuff breaks, I guess. But yeah, all of this happens automatically. Yep.
Yeah, can you go to the label node real quick and click on it?
Sure. Yep.
So the first thing, if you do debug node on a label node, you get the static UID.
Mm-hmm.
As somebody who's developing stuff using visual scripting, what is the benefit of that for us? Like, how do we make use of that?
Yeah, so basically you have some things where, or some nodes that need to be referenced by a different node, and you have some nodes that generate code which needs to be unique. So let's say for a function, you could just copy this function and somehow manage to kind of make these names the same. Like we add some, we have the, in this case, we have sockets, like input fields that are actually unique. But that's not the case everywhere. So we need some kind of unique identifier for things. And this is what the static UID does. So if I go back to the label here, let's just turn this on so it shows for everything. This has this UID, and when I copy the node, this one has a different UID. So the UID will stay the same for this label constantly, like it won't ever change for this node, but it will be unique for every single node. Meaning if you give something the same name, like if you have a function and that function name gets defined by, say, like the label of this node or something, then this function name could be the same as this one, but we just add the static UID at the end here to keep it unique. So it's just something that's like attached to the node and that gets referenced by the node, but yeah, it always stays the same. So
okay. Now,
we also use it for
go ahead.
Yeah, we also use it for like in the panel, for example. If you choose a custom panel here, like this name could change, like the name of the node could change, and we can't choose nodes as pointers, so this is just a string property. So we just keep track of these same nodes by the UID actually. Yeah. Sorry. Yeah.
Oh, that's awesome.
Yeah.
Do all nodes have a static unique identifier, like shader nodes and geometry nodes, or is it just the visual scripting nodes that have that?
It's just the Serpens nodes.
Okay, that's good to know.
So we generate it somewhere in here. Search for static UID. Yeah, we have a property in here, and then when the node gets created or when it's, yeah, we're using some collection stuff in the background. But yeah, then it just gets assigned a UID in here. And actually for stuff like the panel, it's a little bit different. So we also have a property on here called just UUID, so not static UID, but just, yeah, not static. That's kind of the point of it. So it will change. It will be different every time you call self.uuid. So if I go into the panel in here somewhere, .uid, yeah, so we have a function here called update ID name, which uses this self.uuid. So it doesn't use the static ID, it uses one that changes every time we call self.uuid. And the reason with the panels for this is basically just like if you look at the where did it actually?
This is what's giving them unique names every time the compile runs.
Yes, that as well. Yeah, it's giving them a unique ID name when it compiles, and the reason for this is just for things like the default close. So if it was the same ID name, then it wouldn't update the UI here, like you can see it opening and closing, and that's only happening because it's a different panel, like it has a different ID name. If it had the same ID name, this would still be like it would still work for being the default. It just wouldn't show up here because the panel is already registered, like it already exists in Blender, and Blender has already stored that this panel was opened or closed, so it wouldn't update. But yeah, that's just why we use that ID in this case, which kind of like it's a bit difficult to work with because then you need to keep track of what the last ID name was, and then for nodes that reference this node, you need to keep track of when this ID name changes or this ID name changes, and then update that node's code. Like if I have a subpanel which references a panel and that panel changes its ID name, then that subpanel also needs to get updated. So we can go into that in a bit detail, in more detail in a bit, but it's kind of a bit more complicated. So yeah, let's get to that later maybe. Yeah, but generally, like the static UID is something that you can add to your code to make sure that the code that you're generating actually stays unique, even if you have multiple nodes of that type. Yeah.
Okay.
All right. So yeah, I talked a bit about like this compile, like how the compiling works, like going back in the nodes, and when the node receives an update, it updates its code. And the only thing like where you're interfacing with this is this evaluate function. But actually, let's start with the setup of the node because it kind of makes more sense, I guess. So you have this onCreate function, which you will override in your node. And in this onCreate function, you set up everything, like everything about your node. So this is creating inputs and outputs. It's setting default properties if they can't be set in a different way for some reason. Yeah, stuff like that. So mostly creating in and outputs. And the way you do this is just calling these functions on self, so on the node. And you can find all of these in the base node again. So if you scroll down to here, you will see all of the different functions that you have. They're not like, it's not something that you need to like memorize or anything. You probably know the different like socket types that exist, and VS Code should be smart enough to autocomplete this. So if you just do self.add, you just get a list of all of these. Yeah, and it's basically just a list of the different inputs and outputs. Some you have options for adding dynamic ones. Yeah, and you just kind of you call this function. You can optionally give it the name you want. So we usually don't give any specific name for execute or interface sockets. We just leave it at execute or interface. But you should give names to like any other sockets. Yeah, and then you can also set defaults on these sockets. So every socket has a couple of properties, and you can set them by just doing something like input equals like self.add boolean input, and this will return the input that gets created. So you can then do input dot something, and Copilot is actually smart enough to complete Serpens code apparently. But the way you would find these is just to, like, some of these are also in the docs, but you to find these, just go to node tree, sockets, and then you have all the different sockets that exist in Serpens. So I'm on the Boolean socket. So if I just go to Boolean, you will see the code for the Boolean socket, and the only thing you really need to care about is default value, like for this one. And that's just, like, default value is usually the name for all of these sockets. So like float also is called default value. So if I just set self.default value to true, then that socket will be enabled by default. Not sure what the actual default is. For the Boolean sockets, it's false. Okay. So if you don't set anything here, it will just be false. Like, it will just be, the checkbox will just be off, but you can override it in here. And some inputs also have subtypes. So let's say like the float socket has, for example, a factor subtype. So you can do input.subtype is equal to factor. You can see like all the different subtypes here. I think something like the float vector is a bit more interesting. Yeah, this one has non-color, color alpha, and that will just use a different property from these here, both to display and then to give back as the value of that socket. And you don't really need to care about like any of the code in the sockets themselves. It's just really looking up the different properties that the sockets have. So in here, for example, you also have, like in the float vector, you have the size, which you can override, and you also have size editable, which is a Boolean. So if this is true, then you get a little like a little property which will just show up on the socket to where you can change the size. So we use this on function inputs, for example, where you can change the size of the input. So for the if-else node, we just add an execute input, a Boolean input for the condition, and then 3 execute outputs for true, false, and continue. And by the way, like these orders are fairly standard. I think we're not like at a fairly good place where like these are always in this order. If you have multiple outputs and then something to continue, like if it's in the interface or if it's in program node. So if you're creating a node like that, I would just like look at similar nodes to kind of see what the standards are. So this is the onCreate function. This gets called once when the node is added, or when only once when the node gets added. So this is what you would use then. All right. So then to the kind of most important functions, and this is probably where you will like do most of the actual work. This is the evaluate function. So this is what actually gets called when a node receives an update. So if I have my separator here and I attach a float to this input and I change this, then the separator will get updated, meaning this evaluate function will get called. And as you can see here, it basically just overrides a bunch of properties. So this is in the case of the if node, it's just overwriting self.code. In the case of some other nodes, it's overwriting more than that. So the panel is like a pretty complicated example. You can see there's quite a bit of code in here, but it's also overwriting self.code, and it's overwriting self.code register, self.code unregister. And then there's some nodes, let's see, like I think the print node, for example, which, so in the print node, in the evaluate function, you can see it's also setting code imperative. So we have self.code, self.code imperative, self.code register, and self.code unregister. And again, you can find all these in the base node. So somewhere up here, you have those those properties. And the last one we have is code import. So I think what's a node that uses an import? Actually not sure. Prime node. Raw nodes, I guess. Yeah, so like the code import is just for defining any imports that are not imported by default. So BPY and math, I think, are the ones that get imported by default, and anything else you will define in code import. All right.
Oh, that's how you do that. I was wondering how that happened.
Yeah. Okay. So then what you actually do to write your code, like this maybe looks a little bit complicated, but it's actually not that complicated if I just write this out in like what it's actually saying. So let's just say if true, and then just pass else pass. So this is basically the same thing here, just the true and the pass are getting replaced by these here. So we're using a formatted string here, and for most nodes you want to have them go over multiple lines. So this is what the three quotation marks here are for, just to make one string that goes over multiple lines. And then in here, you can use these curly brackets to insert code into the string. So in this down here, it's just a string. Like this is purely a string. There's no extra code in here. But we of course want to replace this true by whatever the value of our Boolean input is. Like we want to use the value of this Boolean input to replace this true here. So we do this by just adding curly brackets, and then in here accessing the value of this Boolean input. So Copilot again is smart enough to autocomplete this, but the way we're doing this is just adding self.inputs. Calling self.inputs, which is a list of or a collection of all the inputs of this node. And then I'm accessing the input called condition. So that's the name you define up here. You can also use the index in here. So we could say like this is the second input. So you could say index 1. But you can also use the name. If you do use the name in the curly brackets, I think you need to use single quotes and not double. But
I recommend using the name when possible.
Yeah, definitely. Like when you change these inputs, especially like while you're still developing the node, then the index will change, and the name will not change as much.
That's why I recommend the name.
Exactly.
It saves time and frustration later.
Yep. So on this input, the property we want is .python value, and what this does is if I go into the Boolean socket again, we have the default value, which is actually the property being like false or true, being like a Boolean. But if I go into the scripting socket, which is just like a base class for all of this, and I go to Python value, then you see in here, like we have this get Python function, which does a bunch of stuff we don't need to care about, and basically just converts this value into a string representation of that value. So for the Boolean, you can also see this function here, get Python representation. For the Boolean, it's really just taking the default value and turning it into a string. For something like float, maybe float is also simple. This one's a little bit more complicated, I guess. It's taking the attribute, like for whatever the subtype is right now, like it's just taking the value, converting it to a tuple, and then taking the first part of it depending on what you defined as the size for this vector. Something like string is also interesting, because for the string socket, while you still have a default value where you're getting a string value back, For the Python representation, it's a bit more complicated because we have different subtypes for the like directory paths and file paths and so on. And by the way, yeah, this is also something like, again with the subtypes that you can set on the sockets you create, so file path and dir path. But for the Python representation, we're like changing stuff like the backslashes in here and so on. And we're also making sure that you don't have two different types of of quotations in the string, because that will like break Python. Like if we make a string here, let's just like say test is equal to just an empty string, and then I add a single quotation in here, that's fine. But if I then also add a double quotation, like this won't work because Python thinks this is ending the string, which it isn't. So we're just making sure that there's only one in there. Could probably be better ways for handling this, like adding backslashes, but that might break in other places. So we're just going the simple route here. Yeah, but what's really interesting about this is that we are returning not just the string value, but we're adding quotations in that string that you're getting back. So it won't just return you a string value, it will return you a string value with quotations. And the reason for this is that you're inserting this into the generated Python code. So if you would just get back just turn up Copilot actually for this, because it's maybe a bit distracting. Like if I say print and then I would insert the value of some socket in here, like let's say the first socket would be a string socket, then the way this would look in my final code, like when this gets processed, like the brackets get replaced with the thing that's in the brackets, let's say my string says test, then it would just say print test. And like this is not valid Python, because like Python thinks this is a variable, but it should actually be a string. So we're returning the representation, the Python representation of that socket's value, which would in this case be like quotations around test. So while you still, like if this was a string input, it would return not just test, but it would return test with the quotations around it when you call .python value on it. Yeah. So in this case, like for the
I have a question on this topic, if you don't
Yeah.
mind me jumping in just
Please.
quickly. I ran into a problem where curly brackets will represent like I guess inserting into self code. But what if I need curly brackets? How would I have them inserted?
We're doing this on here, for example, in the panel for the BL options. So yeah, it gets a bit messy. I recommend I think it's called colorize. Yeah, the extension which colors the brackets. It's more useful for JavaScript than Python, but also in here. So basically what you do is just double curly braces. Like if I wanted to insert brackets in here, I would just do double braces, and it would kind of tell Python that this should be interpreted as one in your code, or in your string, instead of one inserting a different one. Yeah, so it gets a bit messy because we're like there's 4 braces here. But
it makes sense though. That's cool.
Okay. Right, so yeah, this is how you basically access the value of one of your inputs. And the nice thing about this is that you really don't need to care what's attached to that input. Like you could, in your nodes, you could attach anything to this condition. Like you could attach a bunch of Boolean math nodes, you could attach a property coming from somewhere. You could even attach something that's not valid, like you could attach a panel node to this Boolean input. And Serpens handles everything about that in the background. You just call .python value, and what you will get back will be the value of whatever is attached to that input. Unless it's not a valid input, then it will just return the default value, or the value that's currently set on that socket. Yeah, so that's kind of a nice abstraction there. Yeah. And then for the for the else, so let's just skip over this line here, but for the else, what we're doing is actually completely skipping this line if there's nothing attached to the false output. So we only want to like actually generate this code, and this is kind of an optional thing, like you don't need to do this, it's just kind of nice for getting pretty looking readable code. Like you wouldn't just have an empty else hanging around in your code, you just wouldn't write it. So the way we're taking care of this is by wrapping this entire thing in curly braces and saying the else should only get added if the self.outputs false Python value. So that's just this false execute output here. The Python value of this, if that value is not empty, then add the else, and if it's empty, then just add an empty string, meaning this line here in my code will be completely empty, so this just won't exist. And the reason we're doing the .strip at the end here is just to get rid of any like empty spaces, so this just removes any white space, line breaks, and so on. So yeah, it's just checking like if this output is completely empty, if there's no code in this output, meaning nothing is attached to it, then then don't add anything. If it's not empty, then add the else here. And the same also happens in this line. So we have the if there's something on that socket, then add the code. Otherwise, just add an empty string. Okay. And I now I can actually get to this line. So it's kind of the same thing in here for the execute sockets. And by the way, this is the same for any program socket, meaning execute or interface sockets. You usually want to use this indent function here. And you don't need to use this for data, because we're inserting something that goes into one line. Like we know this condition will only return a Boolean. It might return a Boolean that's like a bunch of like this and this or this, but we don't really care. Like at the end we know this will like end up as one Boolean value, like as what Python interprets as one Boolean value. So we only want to insert this into the existing line here. For the execute output, we don't know how many lines of code will come back. Like you could attach a bunch of different nodes to this, and it could be an entire program that goes into this if here. So we need to indent all of these lines by this amount, like the amount of tabs we have in front of this node. And this is something I kind of want to rework at some point, but it's the way we're doing it right now. You just kind of count the tabs you have here. So VS Code makes this easy because it shows it. So 1, 2, 3, 4, 5, 6. We have 6 indents in front of this line. So we just call self.indent, giving it the Python value of our true output, and then telling it of how many tabs it should be indented. So however many lines get returned from this .python value, from this true output, it doesn't matter, because this indent function will indent all of them to go into the if here. And you want to make sure that this matches, otherwise you're like you will get syntax errors, because if you attach more nodes to it and they generate more lines, then those lines will just be on the line of this else here, for example, and it will just break. So this is the indent function here, and we're doing the same for the false output here. And then the final thing is that we also need to do this for any socket that comes after. So it's maybe kind of like a bit intuitive that you would say like, okay, I have this node here with an execute input and execute output. The execute input, like I don't do anything with this. This kind of happens automatically. Like at least from your perspective, like when you're just writing this node, but it doesn't actually, because you need to take care of writing the output. So you don't need to do anything with the executor program input, but this node here does. So this node takes care of using its output value, meaning the code coming back from this node, in its own code. So you need to do the same for your outputs. And we're doing this, like for the if, it's fairly obvious because we have outputs that actually go into specific places in your code. Like this should go, the true output should go into the if, the false output should go into the else. But then we also have a continue output which should just go after everything. And this is also like for the loop node or something, like we just have this for loop, we have the repeat output here, and then we have the continue output just after everything. And for something that's like less obvious, like let's say the report node, which just has an execute input, string input, execute output, we're also still adding the code for the execute output in here. So you always need to define where should the code getting that's attached to my outputs, where should it go in the code that I'm generating.
So you're almost always going to be using the self.indent, comma, either 5 or greater, right?
Yeah, I mean, you could
Depending
just
upon how many indents
move this back. Yeah, like technically you could move this back all the way here, and you don't need to use the indent function because you're all the way on the left. Like there's nothing to indent against. But the reason we have this is just because it's nicer to look at code that looks like this.
Yes.
And like at least to me, then if it's like outside of your class, like Python uses these indents for a reason. So we're just using the indent function here to make sure that that code is actually indented, but you can still like place it here.
That makes total sense. I think I probably need to, I don't know if I did that for my my program node. I probably ought to go back and fix that.
Yeah, it's something that you need to test, like just plugging in something at the end of your node and checking if it still works.
Oh, I did. Because... yeah, it broke and then I had to update it. That's right.
Yeah, it happens to me as well. Like sometimes I just miscount or I like indent, like I put this into an if and indent the whole thing, and then all of these are wrong. So that's also one of the reasons why I kind of want to automate this, even though I'm not like entirely sure on how that would work. But it would be nice if you could just like place this and it would happen automatically to that it's indented the right amount, so you can't mess it up.
You have to do that for both program and interface style sockets. So add like an interface output.
Yeah, so we're calling the diamond sockets in general just program sockets, and then it's either execute or interface. So for all program sockets, you need to define like where it should continue.
Okay.
For the layout sockets, don't you have to pass through the active layout as well?
Yeah, exactly. So yeah, we can get into that now. So this is something that's fairly recent, like a fairly recent change, I guess, like last or second to last update or something. But before we just didn't have outputs on most of the interface nodes. Like the nodes we had it for were trigger nodes, so nodes where isTrigger is set to true. And then we also had this layout type function, which would return the current layout for that node. So because we have something like the label node, which where the code actually needs to access what layout it is in, it kind of needs to go in the other direction than everything else, because like as I said, all the program sockets go right to left, like this button updates this, updates the panel. But in this case, it's the other way around. Like this label needs to know what layout this panel to the left of it has. So this is what this self.active layout does. And when you define an interface output, let's say on the row node, then you need to define the layout type function. So because this is creating a new layout, and any interface outputs that you have on here, like this dynamic one, needs to pass along that layout type. So if label go, there we go. If this label calls self.active layout and it's attached to a row node, it should get back the layout type row. So this is why you need to define that function for when you're creating a new layout. So for the row, what we're doing is we actually have multiple outputs here. We have just an interface output which should pass on the previous layout, I think. Yeah. Oh, actually, I think there's something missing here. Whatever. But if you actually attach to the socket, so this layout type gets the socket that is requesting this active layout. Then we want to return the name of the layout we're in. So this row underscore self.staticUID is also what we're defining down here to actually create our layout. So this is where we're calling like .row to create the layout. You can see here like even the row uses its active layout from the node before, because this row could be in a column, for example. So the column would return its active layout, and the row would use that layout, and then the label which is attached to the row would use the active layout from that row. Yeah, and because we now have interface outputs that just kind of pass through the layout of the previous node. So like, let's say I have a row and my label is in that row, and then that button is attached to the label. This button, this would be the same thing as attaching this button to a different input of that row. So if this button calls self.activeLayout to know what layout it should go in, it still needs to know that it's coming from this row and not from something like whatever this label is. So this label needs to pass through the active layout that it is in through its output. And the way we do this is just on the output you're creating on that label, just set path-through layout type to true. You don't need to define a layout type function. You're just telling this like pass through the current layout type, and whatever that is, it will get passed on to the next node. Yeah, so this is only relevant like if you're creating interface nodes. But if you do, you should like make sure this works. Like just put your node in a bunch of different scenarios, like attach it to the end of a node, to a panel, to a sub layout, to a function is also important, because a function actually, like one of the attributes of an interface function, the first one is the layout it's currently in. So if I create an interface function and I place it in this row, it should get this. It should still get this the layout type of whatever the row is in. So it needs to be passed along. So just like when you're creating an interface node, just test that these things work. The only things you really need to worry about is to define a layout type function if you're changing the layout. So if you're doing something like creating a row layout, and the next thing that gets attached to this node should also use this layout type, then define a layout type function and just check the different nodes that we have that do similar things to see like how these work. And if you just like add an output just to keep going for nodes that you attach, just set pass through layout type to true. All right.
That makes sense.
Okay, so yeah, this is basically the self.code. So self.code is the main part of your code, which gets inserted into the previous program node. So in the case of this if node, when I call self.outputs true Python value, and I have some node attached to this true output, then this Python value will return self.code from this node that is attached. So if I have a print node attached to this true output, the self.code attribute of the property of the print node will get inserted into here. And this is just the way the code gets generated from right to left. So starting at like a print node on the right, it would get passed onto the node before it. This open panel node would get inserted into wherever this node defines in here that this code should go, and then this repeats until we're all the way to the left on some trigger node. So this is actually a trigger node, but like if I have an operator here, this would be a trigger node because isTrigger is set to true. And yeah, this would insert the self.code into its own self.code and then register this operator. So if I look into debug nodes here, you can see the code, and you can see this on all of the nodes. So code is self.code. So yeah, whatever you set as self.code here, you will see on the node as code, and then you will have some other ones on the different nodes. So you will have code imperative, code register, unregister, and imports if you define that.
Can you explain the difference between imperative and self.code quickly
Yeah.
I
as
was
well?
gonna say I have the same question.
Absolutely.
Mhm.
Okay, so I think the best example is probably the print node. We're actually using it for on the okay, I see. Yeah, so on the print node, if I go into the print node, you can see that we're setting self.code imperative to a function called snprint. So we're actually creating a function in here, and then in self.code we're calling snprint. And the reason we're doing this is because we want, like, we always want this to do the same thing. We don't want to write all of this every time we're just inserting this line into the previous node. So you can see, like, on the open panel node, it only shows the snprint line. It only shows the code value here. It doesn't show code imperative. And this is because code imperative just gets inserted at the top of every file. So if I enable keep code on here, and I just look at how my log looks, at the top of my file here, I have this snprint, which I defined for code imperative. And then somewhere in my operator here, I have this snprint, the self.code value.
Oh, that's how it's getting up there. That makes total sense now.
Yep.
So it's
So
like a
the
global for defining things.
exactly,
Think of it
and
like the script node
different
defining
word
your
for
functions.
yeah, a different word for global is just imperative. So like in Python, if you write code outside of classes, like if I would just like do print test here, this is imperative code. Like it's at the top level of your file. When you run the file, this is what gets run. And like the code in a class is not imperative, like it's nested. It's object oriented because it's using classes. But yeah, so that's just why that the name is code imperative. But basically, like, what that means is if you have code, like if you have some function, for example, that you want to run multiple times, let's say like you have this and you want this to be just a single line. You don't want to repeat all of this code all the time. It's just the values that are changing here. Then you should just write code imperative, write your function in here, and then just call your function in self.code. And then that will move your the function or whatever you define in code imperative. Like you could also say like print something in here in code imperative, and this would get added here, which like that's not really useful because it will like run once when the add-on gets registered, I guess. But like that's why we're using this usually to define functions or classes maybe, or like global variables if you need them. Yeah.
So a question on that topic then. Say if you do like a code imperative on one node with a function on a completely different node, can you then reference that function?
Because we're using a single file to like all of our codes get generated in a single file, you can. You just need to make sure that that node exists. Like if you don't have that node in your add-on anywhere, then this function also won't exist. And it also, like, it will only exist when it's actually getting registered. So if I just add this print node here, but I don't attach it to say this operator to some trigger node, then it also won't show up here because it's not getting like it's not getting added to the main add-on file, which is what these trigger nodes do. Yeah, so you need a node that's actually being used that defines this function if you want to use it in a different node. You can just define it again. What this format code or remove duplicate node code does down here. Like if I duplicate this print node and I look in here.
That was going to be my next question.
Oh, it's not. Yeah, and I attach these.
This makes way more sense now.
Yeah, then you will see like two print functions, because these are defined. This is getting defined by this node and by this node. So this is what the remove duplicate code does. If I just recompile this, we'll just check like what functions exist in here that are there multiple times and remove the duplicates. If you had ones that had the same name, like only one of them would stay, but you shouldn't, like, yeah, choose unique names, I guess, to make sure that they don't get they don't get overwritten. And this is also something where you, like, if you have a function that actually has a unique, like does something unique for that node, like based on your settings, you can add the static UID at the end here, and then the remove duplicate code won't get rid of it because that UID only exists once. Yeah, but generally, like, this duplicate code removes the imperative stuff that is there multiple times, but it takes a millisecond or something, so it's not on by default. This
Yeah,
should
I've always
also
had
get
it on. I just never knew. I knew it was removing duplicate code. I just didn't know like
yeah,
the
like
context around how it was doing it.
Yeah. And also, like, for the format code, like if I turn this off and just turn on debug nodes, you can see like a bunch of empty lines in here. And this is just kind of laziness, I guess. But it's also like your code would get kind of ugly if you wrote it in a different way. But like in here, we have a bunch of stuff which we're just defining up here, like depending on what pop-up type you choose. Like we have file extensions for when you choose file pop-ups and so on. We have all of this stuff in here, like the property definitions on the operator node. And if you don't define any of these, like this extensions will just be an empty string. So there will just be an empty line here in your final code, and there's a bunch of them in here. So this format code just makes sure it's more or less nicely formatted. Like it just checks for a bunch of things, like after the end of a function, after the end of a class, and so on. It will just add empty lines and remove other empty lines. It's not perfect, like it's not like for any specific like code Python formatting standard. It's just like making it look a bit nicer. And I think it does an okay job of that.
Yeah, for sure.
Yeah.
That's
So
cool.
this is like what these two options actually do, like the duplicate code and the format code. Yeah. Any other questions on the imperative, or is that like fairly clear? Like, what's the
Yeah, that's really clear now for me.
differences?
Yeah. Back to self.code. Continuing on.
Yeah, I mean, I think for self.code, it's actually like that's like basically it. Like you're defining the code in here that gets passed onto the previous node, and this is the same for execute nodes and for interface nodes. Yeah, and then code imperative is just like helpers again, like helper functions and so on, and global stuff in general. And then you have code register and code unregister. And you could define these in any node, so this doesn't have to be a trigger node. It will get passed onto the first trigger node, like whatever trigger node it's attached to. But yeah, like usually you only define it for the trigger nodes themselves, because the other nodes like don't really need to register stuff. So like in here for the operator, we like this is just where we're calling this line, this register line, and the unregister line. In the case of the operator, like we have a bunch of properties as well. I think this is actually so interesting. I think this is for like property groups and stuff. Not exactly sure, but like in general, you just put whatever code is needed to register your node's code and unregister. and then this will get inserted into the Serpens register and unregister functions.
Oh yeah.
Yeah.
So on the evaluate topic, can you also cover a little bit about how like you would put something in self.code, but then how other things just go under evaluate? Like if you're just outputting something like an output socket just through evaluate versus self.code.
Yeah, I think the for node is maybe like a good example of that.
Or like how nodes that don't have an execute socket, like a math node or something.
Yep. Yeah, let's actually start with that because it's a little bit easier to. Let's just pick like some input node, I guess, like area by type. Add-on info. This one's very simple. Yeah, so actually, and there's one other thing in here as well. But if you have a node that doesn't only have execute outputs or interface outputs, it also has like data outputs. So it only has data outputs. Like the for node has both, but some like data nodes only will have data outputs and no program outputs. And then you still like you need to define a value for this. You need to, depending on what this node does, like what options you have set on the node, what inputs you have, this value should be different. And yeah, therefore you need to like set this value. And this is kind of like the same thing as when you're referencing a value. So for program sockets, you will use this value like this, the socket.python value. You will use this in your generated code. So in something like self.code or imperative or register. But for outputs, for data outputs, you will actually set these values. So again, this is where it's like from for program nodes, it's going from the right to the left through the inputs. So when you're setting self.code, it will get passed through the input. But for data sockets, it goes from left to right. So you need to set the value of the output. And you're not just setting one value on the node like you do for program sockets, for program nodes. You're actually setting the output because nodes could have multiple data outputs. But yeah, any node can only have one execute or interface input. So that's why you're only setting like self.code instead of the input.python value or something. Yeah, but like if we have the add-on info node, for example, just add that in. We just have a bunch of like string and like tuple outputs. And we just want to set this Python value. So in this case, I'm actually using indices. You could use the names and probably should use the names here. But we're just setting this to the current, like the Python value in this case. If I choose an even simpler one, like what's the easiest one?
Boolean math node. Or switch data. How about switch data? Is that one pretty small?
Not sure. I also need to get used to my own ordering. I only did this like the other day, so we'll take a bit. Boolean math. Invert Boolean. Invert Boolean is really simple. There we
Oh
go.
yeah, invert Boolean. There's the one.
Yeah, so on the invert Boolean node, like the only thing this node does is take this input and return the opposite as its output. So you need to set the output's Python value to be not the Python value of the input. So that's like all there's to it. We're only setting.
Boom. There's your package.
It could be a package. Like if you have a node that's this simple, or like code that is this simple, it could still be very useful. Like this is nice about writing nodes like this. It's generally like the code part itself. If you like understand all of this like Python value stuff, self-code stuff, then it's very easy to just take like a small chunk of Python code and move it in here and adapt it to use the inputs and so on. Yeah, it will take a while to get used to it, but then it's fairly straightforward. Yeah, so this is on the invert Boolean. If I go to Boolean math, it's a little bit more complicated. Like we have the different operations in here. Like if we add the math node, we have this drop down, and then we have like some amount of input sockets. So in this case, we're checking if the operation is not, because then in this case, if I choose not, then we only get one input. We don't get multiple, so it's a bit different, handled differently. So then we're setting self.outputs a Python value to be not that Python value, and this should have brackets. I don't know why it doesn't. And if it's not that operation, like if it's a different operation, then not, then it should get all the input values. So this is outside any like string that we're writing, outside of like self.code or something. This is just in the evaluate function. We're getting all of the Python values of all of the different inputs. Actually, apart from the last one, because the last one is the dynamic one and you can't attach any value to that dynamic one. So we're just going over everyone apart from that. And then actually also checking if that socket is enabled. I'm actually not sure if we still have that. We don't actually. But this is for like for the eye icon. So if you have, what node actually uses that by default? Not sure. I guess some like property functions. Right?
Button nodes have the eye icon on them.
I guess if I
on the right hand side.
Oh, yeah, this one.
Yep.
Right, but if I take some operator that actually has properties.
Oh,
yeah.
Yeah.
Okay. Yeah, on the inputs themselves, like this is just a property on the node. But like these eye icons, this is the dot enabled. And I think you can set this node base socket by like if I just look for a lot of properties. Can be, there we go. So there's a property called can be disabled. Is this actually the same one? Yeah, I think the Boolean math node is just a little bit out of date, but the property you want to use is can be disabled. So if you set this to true in the onCreate function when you're creating the socket, then you will get the eye icon on that socket, and then you can check if that socket is disabled, and yeah, use that in your evaluate function. Like if it's disabled for the button node, for example, we just won't like use that property. Yeah. Okay. Yeah, so for the Boolean math node here, we're just going over all the inputs and appending the Python value of that input to this list, and then just joining these values, these Python values, by whatever operation we have selected. So either and or. And we're depending on that, we're joining these Python values with this, so we get one string with all of the inputs separated by the chosen operation, and then we're setting the Python value of that output to be this this operation. Yeah, and this is also like, this kind of shows how you're writing code in the evaluate function, but you're actually generating code. So any code that's actually running in this evaluate function won't be part of the final script that you're generating. Only the stuff you're actually setting like to like .python value or .code, those are the things that will actually go into your final script. Anything else is just like utilities to generate that code, like accessing values. But like I think maybe a kind of common misconception is that the evaluate function runs your node, like it's what runs when the node gets triggered, I guess. Like when I press a button that I have somewhere in my, like that I added to my interface, it will run this node. That's actually not what's happening. Like the evaluate function generates the code, and that code is what gets run when you press the button. So this is all the evaluate function does. Like it's setting some properties, self.code, self.code imperative, and so on, and the code of the outputs, data outputs, to be this generated code. And then Serpens will assemble all of this different stuff into one script, and that's what the like the buttons and so on will run. Yeah. I think like maybe I can just quickly go over the difference between these two. So we have the evaluate function in the case of the add-on info node, which sets the Python value to be BPY context scene as an add-on name. And this is actually the property we're using in here. So if I hover over this, you can see scene as an add-on name. So this is the exact property that we're returning here. So we're actually returning, like we're setting this Python value to be this property, not the value of this property, but this property. So if I look into my generated script, like if I attach this to my label, for example, and I go into my my code here, you can see here like dot label, and the text is actually BPY context seen as an add-on name instead of whatever I have as the current value. Like it's not my add-on, it's this property path, because that's the string I'm defining here and setting this Python value to. But this only works.
Can I ask a quick question? Here
Please do.
you've got like an F, and then quotation marks.
Oh, yeah.
But then at the very bottom output sockets, you've got str.
Yep.
What's the difference between those?
Yeah, so in this case, we don't actually need the F. Like this is very like totally unnecessary in here. It's just kind of, maybe it's probably a copy and paste thing, to be honest. But like you would use the F to be able to use the curly braces inside of a string. Like if I just add them like this, Python will just think these are part of the string. But if I add the F in front of them, you actually need to put something in them. Like this is, the F stands for format. Yeah, like in this case, it's not necessary. Yeah, it's probably just copy and paste. Yeah, and the string is exactly because like because we have this evaluate function and the evaluate export function. Setting this to the data path will only work while you have Serpens installed. So when you export your add-on, you want this to be the value that you defined in here. You don't want this to be the data path. You want this to be whatever the value is. So that's why we have a separate evaluate export function, which you can define. If you don't define it, it will just use the evaluate function, where you can change certain things. So in this case, we want this to be a formatted string. We need to add quotation marks here because this path will only return a string. It won't return the string with quotation marks. So for the code we're generating, we're just formatting the string, adding quotation marks, and adding whatever the current value of this property is. So in the case of these down here, so we have the version and the Blender version. These are tuples, so we're converting the Blender tuple, like float vector or integer vector, I guess, into just a normal Python tuple, and then converting this into a string, because this Python value is always a string, because it's what the final code will look like the generated code file here. So anything you set this .python value to will be the thing that goes into this text file. And because it's a text file, it's a string. So if I set .python value, it actually needs to be a string. Like I can't set this to a tuple. I need to convert it to a string. Does that make sense?
And what's another example of what you would use evaluate export for?
Well, let's see.
Preferences node would have it then, wouldn't it?
Sorry, which one?
The
Oh,
preferences node.
Yep, that's actually a big one. Because it works completely differently in during development than it is
It's
during
running
export.
inside a Serpens custom menu, and when you export it, it becomes its own add-on prefs.
Yeah, okay.
So
Yep.
it's actually the evaluate function, the normal one during development, actually registers class. Let me see how this works. Property group.
So it's a pretty
Oh,
rare
it's actually a
case that you
function.
would use it.
Yeah, it's only if you need to have different behavior during development than you have during export. It shouldn't happen a lot, but in the preferences, we're actually just creating a function during development. Like we're not creating a preferences class or anything. We're just creating a function and then displaying this function in the Serpens preferences. But then on export, we're actually creating the whole add-on preferences class and everything. Yeah, so this is just another use of that.
Cool.
Something like
the only downside to that is it's hard to use the Python generated values. Like if you made properties in your preferences, and you're trying to access them in scripts or something while you're also developing with visual scripting, you end up like this evaluated export versus evaluate. It jacks with the properties when you're using them that way.
Yeah.
At least for me, it has. So you just have to be careful, like what you use it with.
Yeah, this is something I want to tackle with the file-based compiler thing. I've been
yeah, that would solve it with the file-based compiling for sure.
Yeah, just to completely generate an actual add-on while you're developing, but that's a bit still out there.
Big project, Serpens 4.
I didn't
I
think
guess so.
Serpens could get any better, but now that you've mentioned the whole file-based compiling thing, wow, that's next level.
Dude, it's so cool. He's already doing it with packages. It's gonna be Serpens next.
No, it was. I think it was the at the Blender conference. Bradley, the guy who's doing the molecular add-on stuff, the displaying the molecules and so on. He mentioned that he was still using Serpens, but it was getting a bit difficult because there was no real good way to collaborate with people. It's difficult to have a history for a blend file. You can't put that on Git and hope that specific parts get added and specific parts don't. So it was kind of the thinking, if we have the actual add-on be just files, and then we can replace certain parts with Serpens, then we can have some people just working on scripts, and we can have some people working with Serpens. And so that was kind of how that started, but it's it's a very big project. Maybe the last Serpens project. I'm not sure. we get
I'm glad it's inspired you to I'm glad it's just inspired you in general to explore the idea at least. That's cool.
For sure. Yeah, I think actually the most obvious example for evaluate and evaluate export is the asset node, because on just normal evaluate it just adds the path that you define for your asset, and on export it adds the whatever, it converts the path of the current file. It takes the directory name of that, which would be the main directory of the installed add-on, and then adds the assets path onto that, and then the name of your asset. So it actually uses the path for the exported installed add-on in evaluate export, and just the path you define for your asset in the normal evaluate function. So this is, I think, maybe a good example.
That's a perfect example. Yep.
Yeah, that's something I was missing. I was trying to make a draw image node, like you draw quad and draw line and all that, and I couldn't figure out what was happening there, yeah, with the evaluate export and that sort of thing.
Yeah, for selecting image, I guess. I don't think we're using it.
Yep.
Okay.
So that the image gets exported and all
yeah.
that sort of thing.
I mean, I guess you could
Oh.
just use a file input,
Yep.
because then people could just hook up assets, and then the asset node would take care of that. Yeah, I guess
yeah.
it depends on like what you want to do specifically, but maybe that would be
Mm.
an option as well.
It was too advanced for what I at my skill level at the moment anyway.
Yeah, but like that would just be like adding a string output, or sorry, input, and actually it doesn't really make it doesn't make a difference to define subtypes on outputs. It's kind of like changes over time, and some of this is still in some of the nodes, but yeah, you would just like on your input define the subtype as file path, and then you could select a file on that or attach an asset node. Yeah. All right.
On the topic of outputs, can you run over quickly too, like assigning a UID to outputs?
Like for what specifically?
Well, I was making like a create material node the other day, and I wanted an output for the material that's being created, and I think I figured out that like the node sort of the socket has to reference like self UID to keep it unique. Because like if I grabbed a create material node and then in the next node in the tree I also create another material node, the output socket will just return the very first node that got created, like material that got created. So like the output sockets needed to have the UID attached to them so that they represent the material that's being created on that node.
Yeah. Yeah, I mean, we can either like just go over the for loop here, or we can just implement that node, I guess. Yeah, either one. I guess I can just quickly go over the for node because it kind of does this.
Yeah, sure.
Yeah, so in the for node, we like in self.code of the for node, we have the actual for loop. We're going over the index in the range of whatever the input is here, and if it's reversed, then we're going in reverse order. But then the thing we're iterating over, so like for I in range and then something here, this I actually has the UID at the end of it. So we have I underscore and then static UID. So again, like we're not using the self.uuid here, we're using the static UID because it shouldn't change ever for that node. It should always be the same value. And then we want to use this I for the index output. So if we have our for loop and we reference this index output, it should be the value for this for loop. So if we have a for loop and a for loop inside of this, if we reference this index, it should give back the index for this node, and if we reference this one, it should give back the index for this one. So this is kind of the same thing, I guess, like for your material node. Yeah. So yeah, the way we do this is just by setting the Python value of this index output to be the same name as we define here for this this value in the for loop. And the reason this works is if I just like add a trigger node here, and let me just change this to list, so just get empty list in here, and then I can use just the print node at the end here with the two indices in here, and go into my script. I get the function for that somewhere. Oh, okay. Oh, does it not work with an empty list? That's interesting. What's something objects? Yeah, okay. So then you can see like we have the static ID for the first for loop here. So if I actually go to like debug nodes, then we can see like db whatever and 53, and we can see db 53. So these are our two for loops here. and we're in our code, we're just saying I underscore whatever the static UID is, and in our code it's I underscore whatever the static UID is. And then we're setting our output to be the same name as we defined for this variable here. And then when we attach that to the print node, we can see it uses this output. So our output is a variable name, basically. It's not a string, because we didn't add quotation marks around here, like extra ones. It's just a variable name, which gets passed on through the socket to the print node in this case. Yeah, and so we're basically just using the same UID to define the name of that that variable we're assigning to the socket, as we're using in the for loop here. Yeah, does that make sense?
Does for me, because I've encountered this problem.
Yeah.
Well, that explains the static UID on a node a little bit better too now. Like
Yeah,
you
you
would
need
wanna-
it. Otherwise, if you got variables on different nodes, but the variables have the same name,
Yep.
they need to be unique.
Yeah.
Yeah, that's beautiful. That was a great question.
And actually one more thing about the sockets. So we have this reset value function, which, like in this case, we're using it because we're setting we're setting this Python value to be the index of the for loop. But if nothing is linked to our if our first input, which would be this collection property, if there's nothing attached to this, we don't even want to create the for loop. Like we don't even want to create self.code. We actually in here we have a print telling you that there's no collection connected. So depending on if the socket is linked, we're doing different things. Either actually creating the for loop and setting these values, or creating just setting the self.code to this debug print basically. And this works a little bit differently for self.code and the other self.whatever code something than it does for the outputs, because the outputs remember their values and self.code gets reset. So what this this basically just means, if evaluate gets called and you don't do anything to self.code, like you have an if here and in here we don't do anything, self.code would be empty afterwards. You need to set this every time you want this to have a value. You can't just skip it one time in evaluate and it keeps the same thing. It will be a different value. It will be reset to just be an empty string. But this is different for the outputs. They will just remember the value, the Python value that they have. So you just will call this reset value function. Yeah, it's probably not something that will happen too often, that you will encounter too often, because usually you just set self.code and set the output values, like whatever is connected, you will just deal with it. But sometimes it's like this node won't do anything if you don't connect something to it. So we do different things depending on some property, for example, or if some input is connected. And in that case, we're just resetting those values. If we don't, it doesn't really matter. They will technically still keep this index, and it might throw an error if the user actually runs this. But yeah, it's technically it's technically a user error. It's just something to avoid it actually throwing an error, because we're just resetting it to whatever the default is, meaning for the index it's something like 0, and for the item it's probably just none. It's a property output, so it would actually still print something, and if it's still I underscore static UID, but self.code isn't set anymore, it's empty now, then this for loop doesn't exist and this I underscore doesn't exist. So we're trying to print something that doesn't exist if we're accessing the value of this and we're not resetting the value before we access it. So yeah, maybe a bit abstract if you don't, like if you've never encountered this in developing a node, but when you do, just know that this exists and you don't need to like figure out what the default would be. Like you could just say here for the index like equals 0. This would do the same thing. It's just reset value just takes whatever the original value of the socket was before you gave it 1 for the first time and sets it back to that. Yeah, okay.
Yeah, that's pretty handy to know, actually.
But if you defined a default value, it would set it to that, right?
That's actually a good question.
Like if you
I
did
don't
a
think so.
self-input Boolean and you
Yeah.
set default to true, and then you did reset values, would it reset to true?
I think it would reset to false, like just to whatever the default value of the socket is and not what you set it to.
Oh, okay, that's good to know.
Yeah, that's actually an interesting. It should be different, but I actually don't know how I would do that. Well, I guess, yeah, whatever.
That's fine.
it's just
there's the method there anyway, so
yeah,
reset values just as good.
Yeah, like if you're setting it up here, then you could also just say like equal to whatever you set up here. Yeah, it should technically go back to whatever you define as a default. Yeah, something to think about.
Yeah,
okay.
that needs to be changed right this second.
yeah, sure. Okay. Yeah, but I think this is like mostly it for the code generation. Like this is where most of the, I guess, the magic happens. This is what actually like does something, where you're setting self.code, code imperative, register, unregister imports to be the code that you want to go into the final script, and you're setting the outputs, the data outputs, the Python value, and those to be whatever should be used by the nodes coming after that. Yeah, and Serpens will take care of the rest. Yeah, any like other questions on that right now? Because I mean, there's still more stuff like drawing properties, references to other nodes, and so on. Yeah, but if there's any questions on this right now.
Not that I can think of at the moment.
Let's just very quickly do the draw node because that's pretty simple. Yeah, so basically,
yeah, this sounds cool.
Yeah, my key map node uses this a lot.
Yeah, so I guess technically we shouldn't use it too much because it slows down the UI. Like normal Blender nodes.
Yes, it does.
Yeah, apparently like normal Blender nodes don't really use a lot of elements on the nodes. Like they use like maybe a drop down here and there, but other than that, it's like most nodes don't have anything. I guess there's like special cases with like a float curve or like a color ramp or something. But most nodes just have inputs and outputs.
Yeah, I turned debug nodes on a massive grass one time, and it just like brought it to its knees.
Oh god, yeah.
Drawing on all the nodes. I love that you added the debug only selected. That was such a cool.
Yeah.
Oh, that was.
Yeah, but basically, if you want to use it, which like there's good reasons to do so. Like if you have properties where it doesn't really make sense to have an input, then just put it on the node. So what you would do is just define a property like you do normally in your scripts in this node, and then just display it. So just like you usually do in a panel or something, just for the draw node function. And then you also have the draw node panel function, which gets drawn in here. So if I go to like the panel, then you can see there's a couple of extra like properties that aren't shown on the node, but only in this panel here. And like if you use this, know that users won't find this. Like this is hidden, and it's not something that's like meant to be discovered really, because like no one just clicks randomly through nodes and happens
I
to
do.
stumble upon something. Yeah, okay, maybe power users do, I guess. But it's like not something the average user. Oh my god! Apparently, this is something that people do. Okay, never mind.
Yep.
Uh, good to know. Yeah, okay, but still, it's hidden. We still get questions about like panel width, especially because it's hidden in here. It's not something that you use all the time. It's actually something that you basically like never use. But it can't be defined as an input because it can't be like it can't be used dynamically. You can't plug a different node into this input and expect it to work. Like it needs the panel node needs to be re-registered when this value changes. So it needs to be a property on the node. But this one is like this is so rare that like we're not even putting it on the node itself, just putting it like hidden away.
But it was only a design decision that you did that for, right? You're just like, I don't want to muddy up the
Yeah, I
panel
just
node,
don't
so we'll
want
have
to.
it here instead of on the
Yeah,
node.
like we already have nodes that are pretty big. I still don't like the layout nodes that like that's just too many inputs, way too many inputs. But I'm not exactly sure how I would change that. I'm thinking about it. That's but, either way. Anyways, we have the panel node, for example, and we're hiding away some of the properties because we barely ever need them. And like in this case, there's special ones as well. Like for the picker here, if you select something, I guess that was default. Let's just go like this. Then you can see this updating. Like these are the ones that are getting set by the picker. So in theory, like if you know these for something, you could set them here. Yeah, and you can also use the override, which I guess is more useful in some cases, like for the file menus and stuff, for opening those. But
That's actually the most common question I get all the time is I want to call something
yeah, I
like call a
just
panel or call a pie menu, and you
just
have to
added
override
nodes
the
like
ID name.
right before this for open panel, open menu, and so on. So now you can just trigger.
Oh, have you added this in?
Yeah, I just added it like a minute ago.
Oh,
like
that's so
right
cool.
before this.
Wow.
So like if I select this node here and then I run this, then it will actually like call the menu.
Holy
so
crap, that's awesome.
we have this like these are also very simple. Like this is just calling this operator. The difficult part about this one is like adding the picker and so on, which also is like too messy right now. There should be templates for this, like templates that you could use in your node, but like right now it's a lot of duplicate code.
Yeah, referencing variables and all that sort of stuff as well is like I'm just copying big chunks of code at the moment.
I mean, I do the same. I just happen to have written it in the first place, but apart from that, it's the same thing.
That's fine.
Yeah, like it should be just templates that you're integrating in your nodes.
Why does the Serpens have an AI for us? Come on, Joshua.
Working on it. Working on it. Well, not specifically for Serpens, but well, it's coming. no, not that either. Different project.
Oh boy.
Yeah, it's coming at some point.
Wait, you're working on AI too? Oh my goodness.
it's still joking. A bit out. Nah, it's too interesting of a thing to not be part of.
That's true. That is true.
It's just difficult because it's moving so fast. Like it's so hard to keep up with even what's happening, like, and even harder to actually know how that stuff works. So yeah.
Then we'll need AI to be able to tell us what the AI is, where it's up to.
That's right.
That's actually already kind of possible.
Wow.
Like, I mean, all the like chat GPT stuff. That's GPT. Is it GPT chat? What did they call it? I don't know. It's kind of a weird name. Like it's kind of the wrong design for doing that, but it's technically possible. Like if you have some existing data behind that, and then you have some like just language model on top of that to tell you information of that that data. Like it's a question of time, like when this will kind of, I wouldn't say replace Google. Well, actually, maybe replace Google. Yeah, let's say replace Google. Yeah, but it's kind of an exciting time, kind of also a very scary time, because like people are talking about like, oh no, now we have models that are generating assets for us. This will, or images, like final images, but we still have like, we're still creating parts for putting our scenes together, and then we have models that are creating the entire assets, and so we're completely like replacing the entire asset pipeline and everything that goes into that. So it's only about assembling the final image, and then we should just take out meshes entirely and just work in a 3D scene that's not actually consisting of any topology but AI models. So it's weird. It's moving way too fast, and like if you think ahead a couple of years, then everything you work on now is already getting replaced. So I don't know. It's it's
Corridor
weird.
Crew just did a video on a camera that captures 3D space, but I think it's like all point
Yeah,
cloud or something.
yeah,
But there's
nerves,
like no
neural field.
no three
Yeah.
nerves, that's the one. No 3D
Yeah,
geometry. Just bypass it out.
yeah. I mean, that stuff will get interesting when you can start to edit it, and I think especially for games and stuff, when you can start to just like have some assets and place it in there, and everything is pre-calculated, and it's fast enough that you can just move through scenes with real reflections in real time. But yeah, it's coming, and
Crazy.
it's coming way faster than we were thinking. But
Exponentially.
oh yeah,
It's all right. I'll still have fun with my nodes. There's still people who will be excited with stupid things like me.
yeah, that's
for
the
sure.
good things. Yeah.
You'll still have plenty of idiots to entertain, Joshua. Don't worry.
Yeah. Wow. Okay. Wait. Drawing stuff.
We're on the draw node.
Draw node. Okay. Yeah. So you have for the for loop, for example, we have the draw node just drawing the type and the reverse properties. These are just Boolean and enum properties like that we're defining on the class here, and then we're displaying these, and then we're also using this in the evaluate function. So like for reverse, we're like using just the length, or then the length, but going backwards in the for loop here. Yeah, we have the draw function, draw node function, which just draws on the node, and we have the draw node panel function, which does the same thing, but not on the node, but on the node here in this panel.
Oh, I did not know that. Cool.
Yep.
I only just worked that out too.
Yeah. So again, like these are kind of hidden. Apparently, people look at these, but yeah, don't expect everyone to do so. So if you want something to be seen, put it on the node, or better yet, put it on it as an input. But it for some stuff, it either doesn't make sense to have it as an input, like enums often like don't really make sense. Like in this case, we have it on here. I'm not even sure if it's useful, but yeah, whatever.
I know I use it.
I think this one?
Yeah.
Layout ones, really? That's
Yep.
interesting.
I use those all the time.
Okay. I think, I don't know if you're in here, I don't even remember who it was, who did like the math node with different, like with an enum input. So that was kind of interesting. That was you? Okay. Yeah.
So I could use it in snippets, because I couldn't use it in a
Yeah,
function.
yeah. Oh, true, that came up earlier as well for something. Yeah. It's interesting. People do stuff that you don't expect as soon as you give them like the freedom to do that kind of thing.
You want to cover putting a button on a node too, like the trigger node? Because that'll all go in the draw node as well.
Yeah, exactly. This just all goes into the draw node function. Like if you have a button that should go on a node, you can just like define an operator up here or something, you can also just create a different file. Like this will also get, like if you create your package and you have a different file which doesn't contain a node, it will also get added to the install. Yeah, but you can put it in the same file if it doesn't get too much.
I know a simple example of my node is I just put a little button on there that linked to my node's web page. So if you wanted to go check and see if there's a new version of it, you could quickly get a help doc or look up the node. So I just called the bpyops wm or the URL operator. I didn't actually have to create an operator. I just called one.
Yeah, we need a better option to do that kind of thing, because it's like I think it's fine for stuff like the preferences node to like where you really like all the time you're opening the preferences to just when you're using that node. I hope.
Yes.
Okay.
Yes,
good.
I'm using that.
Yeah. So I think for that kind of thing, it makes sense. For something like docs, it should like I think one thing that's really annoying to me is there's the option to have an icon. Like I mentioned earlier, we're not really using those, but you can use an icon up here, and I think stuff like the shading nodes use those. God, that's slow. They don't. What's
Geometry nodes, maybe?
I don't remember. Some node use them, I think, but I don't even remember what. Yeah, they use it for categories as well. But like I think there were in some Blender node. Maybe it was just for like legacy nodes to just show that they were legacy nodes. But I think you could click on them. Like there's at least like a hover effect when you hover over the icon. So it seems like you should be able to click on them and then run something. But there's no function you can define in Python to call something like that. So like it would be very useful to be able to define like a help like a docs thing for your node, and then have a help icon up here, click that and it opens the web page instead of having a full button on the node. But it's not possible right now. So yeah, that's like the better option. I guess this kind of stuff could also go into the panel. Yeah, not sure. Yeah, but in general, like to add a button to your node, just define your operator somewhere, like open preferences in here. Yeah, just like in here, it doesn't do much apart from like, yeah, showing the preferences if they're already displayed and so on. So you can just write an operator and reference that on your node, and then yeah, that should work. But again, like this kind of thing apparently slows down the UI in the node editor, especially. Which I guess kind of makes sense because it was never used by nodes. Maybe it will be more will be used more complicated nodes coming. Maybe not. We'll see.
Well, I know that my key map node has a ton of UI built into it. Probably too much.
Yeah. Maybe if you have like if you actually have a lot, then you can also do stuff like add the option to expand that and hide that. Like just add a Boolean property to your node, display it as like a little arrow icon. So you're able to hide that UI because I guess if it doesn't get drawn, then it won't be as hard on the performance.
Yeah, you can just hide the node though too, right? Just
Don't
hit
you
H on
hide
it.
Yeah, that doesn't hide the UI.
Oh,
I guess
hide...
you can. I guess you can
like
collapse it. Yeah.
I was just gonna make the user do that.
Yeah. I also like thought about adding like a simplify option or something. For hiding UI when it's not being used, or when it's like when you don't have the node selected or something like that. Like only show the UI for the selected node, or only show the UI if you're at a certain zoom level. Could be possible, I guess. Yeah, I don't know if it would actually benefit the performance. I would have to check that. I'd also go ahead.
I said I kind of like zoom level idea.
Oh,
that
yeah.
would be...
Yeah, I mean, it would change like the height of the node. Well, I guess we could do some smart stuff around that. Like only draw a box or something which has the height where the node still is kind of like is very close to the original height, and maybe just drawing a single box is easier on the performance than drawing all the elements, and you still like you don't get nodes changing their sizes. Maybe maybe that's a future feature. Not sure.
Yeah, I don't know
Yeah,
if that's
I'd rather you focus on other things like the multi-file compiler and finish the global search
an AI building AI.
That's
and the AI.
the yeah this this is still
So
difficult.
this is actually really cool. I really like using this when I need to go into it.
Yeah.
Yeah. I don't know if everyone in here actually knows.
They don't.
I don't even know if if it knows any anybody.
I haven't advertised it yet.
I got it. I guess I can quickly, like this doesn't have anything to do with packages, but like you can't do this with a package. Maybe this is a good example for something you can't do. Packages are there to develop nodes. They can't do anything apart from that. If you want to do something like that, you can like create an add-on, like additional add-on that gets installed, like Serpens Wrangler, I guess. Good example of that. Which I think at the lightning talk at the Blender conference, I said Serpens is the most meta of all add-ons, but really like Serpens Wrangler. I think at this point, Serpens Wrangler is the most meta of all add-ons. Because it's an add-on for the add-on that creates add-ons, so it's just one level higher. Yeah, but very just quickly on the global search, like what it's doing right now is just displaying actually all of the data in your blend file. So this was something that's not possible with this search currently. Like you only get what you expand, and you can only search in specific things. But in here, you get everything in your blend file. So you can see here like 102,000 items in total, and you can search these. So if I search for, if I know I want a property that's on my cube, and I know the name of the cube, but I don't know like property, I can just search for cube, and I just like I will see all the options that actually have cube in them. So I could like filter for the different ones. So I can see like we have meshes cube and we have objects cube. So just filter for objects. Then I will get all the objects that are yeah, all of those properties on there, and you can see like this just got added to my search here. And let's say I want to get like a property about blocking something, because I know there's a couple of those. And I will only see like all the properties that match my search here. So I could say like, yeah, lock rotation is the one I want. And I could just copy this. So if I only know that the property is called lock rotation, I could just search for lock rotation, and that doesn't work apparently. Let's go. Okay, what's the uppercase? This is still in developed. Let's just search for lock. Okay, I guess that doesn't work. I need to look into that. Yeah, but this isn't finished. But like you could see, like I search for lock and I can find lock rotation on the cube is the one I want, and then I copy that. Yeah, it's nothing to do with packages. so let's move on.
Cool,
But it's a cool feature.
I think it is. Yeah, it's not quite there yet, but it's kind of the thing that's holding up the update, because I need to put some thought and time into that. Yeah. Okay. All right. Yeah. So I think that's like basically it for drawing. Unless you have more questions.
Just with drawing, also like say if you're gonna do an enum but you wanted it expanded, like do you define that in the property itself or on the draw node part? I haven't actually jumped into that stuff yet.
Yeah, we just make the Boolean math node, like on the draw, we have the layout of prop. And you would just like say expand basically.
Yep.
In here.
Cool.
Yeah, so that's the kind of thing which you can also get from let's say like a display property node, I guess. Like if you just look at the generated code here and you enable expand, then you see that it's, well, if I would like connect a property, then it would add this in here, so you can like check some of these things, I guess. Yeah.
A really
Anything else?
smooth way of using the draw node is just adding a display prop or whatever you need in your Serpens UI, and then just copy that code into the packages.
Yeah, and optimize it out.
Yeah.
Remove the UIDs from the rows and so on. Yeah. All right. When I think these are kind of the like the most important features that you need for writing, I guess, basic nodes, like and basic meaning like nodes that don't reference other stuff, because that's when it starts to get complicated. Yeah, so nodes that reference other
so
nodes.
like if you want,
oh, good.
if you wanted to create like a create material node, like I've been doing, just simple stuff like that, pretty much everything that Joshua's covered is close to what you need to know.
Yeah, and you can also find like all of the specific code in here. All of these attributes also explain a bit. Yeah, also for sockets, the properties on those sockets. You can like there's some like just utilities that you will maybe need. Like you often access the node tree of a node, like of the node you're on right now. So you can just do self.node tree. It's not something that's like on shader nodes or some or anything. It's just for Serpens nodes. So some of these are also listed here. Yeah, and also things like we have these indexable sockets, which are what you find on like blend data nodes and so on. Do we have a node that has that? Oh, the for loop, I think. Yeah, the for loop output just has like this option here, which is not actually indexable, it's changeable. So if you create an output on input and you set changeable to true on that, then it will show this drop down with all the different types, and you can switch between these. So this is like it's useful in some cases where you can have different input types or output. I think mainly output types, because like what's like switch data, I think.
The function return node has it on the input types.
Yeah, function return is kind of special in that sense. Because it needs to know the type to then display on the run function node for the output. But like usually if you have a data input, like just any data type, then the node doesn't really care. Like in this case, it doesn't care what the input type actually is. It is important for the output though, because when you're connecting like this data output into the string input, this print node, or this actually the string input on this print node needs to know what the type coming from here is to potentially convert it. Because like if this was still data socket, I think if I change this, I can't actually change it back. If this was just a data socket, and then it could be anything. Like it could be a boolean coming into this print node, and it would try to print a boolean, which would actually work. So that's kind of a bad example, but like if you have a math node, and this math node had data inputs, and you just plug anything in there, and you don't know what the thing is you're like adding. So you can't add like a tuple to a float or something, or a string to a number. You need to convert the data coming into the inputs, and Serpens does this automatically. But so it like to be able to do this automatically, you need to set these types, and it's mainly relevant for the outputs, because this is what goes into a different node. So like if the node doesn't actually care what goes into it, it can be a data socket, but this node doesn't know what node it will connect to, so it should specify what type comes out of it. Yeah, so this is why we have this. It's something that the user has to set themselves, which is always a bad thing. But I'm not planning on writing a full like type safe Serpens, especially for things like blend data, which is just like that would get very complicated very quickly. So this is just way easier to just have the user pick this. Yeah, because you will also notice when it breaks. Like if you set this to Boolean, but there's actually like a float coming back, then you will get some error for like if it doesn't work, and then you can fix this, fix it.
With the indexable sockets for the inputs, did you see my post about the integer socket acting like a property socket?
I think I did, yeah. But I don't know. But to be honest, what exactly was that? What was that about?
So if I change the indexable input to an integer and I just do a print, it'll say, yeah, this is an integer
I do
socket.
remember.
Well, maybe I was just doing something wrong. I'm not sure.
I think so.
We can talk about that another time, though.
Yeah, I think I need to look at like your specific, like your code specifically. I don't think you were doing anything like wrong in the code. I look at it. I have to look at it. Yeah, but anyway. Yeah, again, the indexable is kind of the same as the changeable. It's just like less types to choose from. Like it's only property, index, and name. So the ones you would use for indexing. Name and index being actually the ones you would index. Properties, like if it's actually, yeah, like one.
What are you doing to set it to using the active?
You don't actually need to do anything apart from giving it the proper name. So if you look into properties, yeah, into the property socket, you see this kind of big object here, dictionary, where, yeah, if you give the input, like if you give an input one of these names here, they will use this value and they will show whatever is set in here. There's no way to define these in a package like additionally if they're not in here. If you need any, like if you have one that's commonly used that's not in here, please just like, and you need that for your node, just let me know and I can add them. I can add them. Like I think these are the ones that are kind of the most common or that came up. There's a couple of special ones for like special nodes, preference, and operator, which have self for their properties. But yeah, this should be the most common ones.
Cool.
Yeah. Yeah, but that's indexable, changeable. You can get the index of some socket. You can hide it. If you hide it, like use this set hide function as a reset value. There's a function to convert a socket. See you. You can socket names, ID names. Yeah, this is just for like if you want to convert a socket, you need to specify the ID name of that socket. So this is something we use for on the for loop, for example. Like if we change this input, it changes to a list. So we call the convert socket function on this input, but we don't want to look at the name, like the specific ID name of the list socket or the collection socket. So we can just use the socket names property on the node. So we can do self.socket names, go to our base node, just search for this, and then we have a list of a dictionary of all these names. So you can just say self.socket names, square brackets, and then the name of that socket. And you will get back the ID name. That's just like a nice utility, and a lot of these are listed in here.
Oh, that is handy.
Yeah. Yeah, and then you have stuff like the node tree, UIDs, the collection stuff. That's for the references, which we can get into. They're more complicated. the active layout, which we'll need for like layout functions. And then like you have a bunch of event functions that you can use. So we used onCreate just for adding our sockets, but you also have stuff like onCopy, which gets called when your node gets duplicated. OnFree gets called when the node gets deleted. Node update gets called on like a bunch of different events. I think when it gets added, when it gets moved, maybe. I think when properties on it change, when you connect links and so on. So it's kind of, it does a lot of things in once. I don't really use it. Link insert, remove, dynamic socket add, remove when a socket type changes, socket name changes, and then again for the reference stuff. Yeah, so those are kind of the events you have to use in your node, and where you can also update your node's code. So this is actually something that's also that like I should probably go into, because like in some cases you actually need to manually call evaluate. So normally evaluate is called when the node gets triggered by a different node. So say like you have a print node connected to a different print node, first one changes, triggers an update on the second one, and that calls evaluate.
Yeah, I'm using that a lot in my node.
Yeah, but sometimes you need to call evaluate yourself. So the simplest case for this is for properties that you define.
Update.
So yeah, exactly. So in the update, like when I clicked or when I changed this operation in my dropdown here, I want to recalculate the code of my node. So I want to call evaluate. So what you do is call self._evaluate, and this is actually important. So the one you're defining here is evaluate. The one you want to call when you want to trigger an update is _evaluate. And the reason for this is that we do a bunch of stuff before the actual evaluate function gets called. So you can see this here in the base node, the _evaluate function. Yeah, it's just an internal thing. For like it does a bunch of stuff like resetting the code, then calling the evaluate function, the correct one. So either evaluate export or evaluate, depending on if your add-on is currently exporting, which by the way, you can use this property as well in your node if you need that for some reason. And then like if it's a trigger node, it will evaluate the connected ones. And then it will check if this code is like, if any of the code has changed. So it actually, yeah, this is where like it's resetting the code, and that's what I was talking about earlier with the calling the reset value on the outputs, but the self.code and so on get reset before evaluate gets called. Yeah, so this is where you want to call _evaluate to manually update your node, but def evaluate is what you're actually overwriting here, like what you're defining here. Yeah, so if you do stuff like create properties which you're drawing on your node, and you want to reevaluate the code when those properties change, then you want to call this _evaluate function. Either like in this case, it's wrapped into a different function, or you could just like put it in here, which yeah, probably you're doing in some nodes as well. Maybe in the for loop. Yeah. So you would you can't do self._evaluate here. You need to get it from the class, so from the class that the base node itself. But yeah, if you don't have a separate update function, just put the base node _evaluate in here, and this will trigger an update when this property changes.
Oh, I didn't know that. Okay, that's cool.
Yeah. There's something where it's like useful to look into other nodes, because not all of this is perfectly documented. Yeah, so it's like, but all of the features that we have are used in nodes. So just find the one that does the thing that you want to do, and it's probably there. Yeah, and if it's not a feature that exists in Zep's right now, it's maybe it's not possible. But if you find one of those, just let me know. Maybe it makes sense to add. Yeah. Okay. I think that's the evaluate again.
For anyone else wondering like what that evaluate stuff is about, like think of it like this: that on the for loop node, there's a reverse boolean. You turn that boolean on. It doesn't really need to update anything specific, but if like you had that boolean change a socket or alter the node, then you need to use like a different evaluate, like a different update.
Yeah,
I think that's how
the code changes, but the sockets don't.
Mm.
Yeah, so for mine, I'm using a bunch of properties on my key map node, and it allows you to pick like specific keys from a keyboard and other things like that. So when those things update, it resets the code to self-evaluate based on those properties to go search and find the key map that you're looking for.
Yeah, I think our key map, like the key map node, is also the most complicated one.
Just
I know mine's complicated.
Yeah, it just needs
sure
to
yours
do a
is
lot
more.
of stuff. Maybe, I don't know.
Key maps are so freaking hard to navigate. Oh.
It's 400 lines, Jesus. Yeah, like there's just like a lot of properties, and then the whole like you have custom ones, and then the picker. Yeah, and then you have the evaluate function, which is big because it needs to do different things for all of the different things you can choose on it. The draw function is also massive. Yeah, so if you want a complicated node, which basically does everything, this is the one. Yeah.
Oh, 1:30 in the morning. Getting late for you, Joshua.
Yeah, well, that's all right.
This has been great. Thank you, Joshua.
Thank you.
Yeah, no, I'm looking forward to seeing more customers. I'm secretly like training an army of Serpens node developers to take over the development once it's like I think I said this a couple of times, like that the eventual plan is to open source it at some point, and then like development should go on to some degree. So we have people that know kind of the how the add-on works, how we develop nodes, and so on. I think that's a good a good place to start from with packages.
And you also put like a lot of effort into implementing the packages. So like it's good that you're going over all this so that we can get a better understanding and then pass that knowledge on and help people make their own packages and you actually utilize the feature that's there because it's really fucking cool.
Yeah, and you can also do like it's surprisingly easy it's surprising how easy it is to add more features, like just Python features to Serpens, because it's basically just like you can just copy a node that does kind of the same thing, change a couple of names, and then paste in the code from whatever Python thing you want to do. Like there's of course like more complicated things where you have a lot of inputs, a lot of properties that you can change on the node and so on. But like for just adding a Python feature, it's super easy to just copy something else and then like just put the only thing you really need to do is change the self.code part.
A good example of that is I found a shot util for copying files, and I pretty much just grabbed I think it was like a path file node or something like that, and just copied all the code, pasted it in, just changed the self.code to what I needed, and just changed an input or something, and it only took me like 5 minutes to make the node.
Yeah,
it was awesome.
I think there's also something where packages can be useful kind of in the same way as GeoNodes is doing now, with like building a kind of base layer of functionality and then letting people like make abstractions on top of that. I think it's for Serpens it's a bit different because we're kind of like we have a base feature set where you can do most things with, and then we have either scripts or now we should also have packages, because like if you want to do a lot of path stuff for your add-on, like most people won't need that, but if you need path nodes, then there could be just a path package which like implements most of the functions from Shooter, OS, like all those packages which the Python packages which handle that stuff. Just bring them into nodes, and then you can just install that when you need it. And you don't need to know what it does. Someone else did before you. So
That'd be awesome for like BMesh. That's such a
yeah,
hectic topic, but that would be
yeah,
cool.
it's difficult. It's difficult to design to be easily usable. Because
Mm.
if you implement all the low-level stuff, then like in theory everything is possible, but it's also hard to use because you actually need to understand like what the like creating a mesh, then
Yeah.
adding to that mesh, then freeing that mesh, and so on. Like you kind of need to understand all of that. So yeah, it's I'm putting off making all of that, but yeah,
Yeah,
if
it's
there's
cool.
packages for doing specific things, that's like definitely a use case. Okay, yeah. I think we maybe can go a bit into the references if you want. Just like the simple the general parts of how it works, because it's I think good to get out there. Even though yeah, it's not the easiest thing in the world. Oh, and by the way, like at the bottom of the base node file, there's also just a template node if you want to have a starting
Oh,
I've
place.
used that. That's where I started.
Yeah, but you can also like copy a node. That's what I usually do. Just copy whatever node is handy right now and delete everything from it. Yeah,
I've
either
done that.
one works. Yeah. All right. Yeah, let's just quickly go over references. What's the easiest example of that?
run operator.
Actually, maybe,
No.
yeah. That could actually be. Yeah, okay. Let's just open the run operator node. Oh, maybe. Okay, it's already a special case. But
okay.
let's try it. Let's try
Okay.
it. All right.
What
So
about variable? Variable's pretty simple, isn't it? Like get
yeah, it's a bit
variable or
different
something.
because it's not referencing a node. It's referencing a.
Oh yeah, true.
It's a node there. Yeah. So this one is pretty simple.
Yeah.
Wait, what is this? Oh, actually, for this one we actually have a template. That's so nice. We should use this much more. Yeah, but let's try the run operator. Okay, so what the node needs to do is switch between Blender and custom. So Blender being the just a paste button where you can just like copy some operator and paste it in. It shows the name. Very useful. There we go. And then we have the custom option for selecting a node of a specific type in a specific node tree. And basically what you want to do is create different properties for these things. So the first thing we have here is the source type, which is just an enum switching between Blender and custom. So this is what you see here. And then we have a property for ref node tree, and it's important that this is called ref_entry because it triggers some stuff when it's changed. Like it needs to, I think for the node tree, it might be like renaming the node tree. Actually, maybe not. I'm not actually sure if this is used, but it's definitely used in some places for the node tree as well. Like if you have a node that references a different node, then the property that for the pointer to that node tree should be called ref_entry. So this is good. Like copy this from nodes that already do this if you're using this. Yeah, this also defines a poll function here, which also comes from the base node, and this just returns if the current node tree is a Serpens node tree. So this dropdown only shows node trees coming from like only Serpens node trees, not like shader node groups or anything.
Oh, cool.
Yeah, and then the property that's actually referencing the operator is a string property. And the only reason why all of this is so complicated is because we can't do pointer properties to any data to every data type. Like, can only do this to like the ones we have we're showing in here, or like I guess in here. Node isn't one of them, so we can't reference nodes with a pointer with this dropdown. The problem with this is that if we change the name of our operator, this wouldn't update. Like usually this wouldn't update because this is just a string property. So we built a whole system around updating this, which is kind of too complicated and already has been rewritten like 3 times just on this version of Serpens because it can be simpler and it still could be simpler, I guess. But like basically what it's doing is there's a message bus event that's subscribing to the to node names, and whenever you change a node, a Serpens node's name, then it will update this reference, and the references are stored on the node tree. So on a Serpens node tree, you don't only have like node tree.nodes, you also have node tree.node-refs. And this is a collection of all the nodes that are in that node tree. So it will have the same nodes that are also in your node tree, but as references, so as a custom like Serpens type. And this happens like automatically in the background. Like when you add a node, it will also add a reference. So you don't need to worry about this existing. But this node ref basically has this is also where the UID comes into play, because the name can change, but the UID can't. So whenever you change the name, the message bus thing runs and updates this name to be the current one. And what it does then is it goes over every node in every node tree that references this node. And it does this by finding ref_ID name of that node. So in run operator, you can see we defined ref_sn_operator node, which is the name of the node type we want to reference. We want to be able to select operator nodes in here. So we do ref_ID name of the operator. It goes through all of these and updates this property. So it sets this to whatever the new name of this operator node is. So when I change this name here, then it will also update on that node, and this will also trigger a recompile on the evaluate function on this run operator node. Yeah, so basically you can use this like a pointer property now, because you can just define a string property, give it a special name, and because of that it will be updated when the source changes. So the thing you have selected, the name changes. But just know that there's like a whole system around that which can break. I think like we had some like it probably still happens, like when you rename operators, I think specifically like Blender crashes, and I have no idea why. It doesn't make sense from the code side. It might be something where we're referencing a thing around a thing, and like setting that like at a time when Blender doesn't like it, but it's like, I guess technically a Blender bug somewhere, and I just can't I can't find it. Yeah, so this is just know that this exists in the background. Like if you're referencing other nodes, all of this stuff happens when you rename the node that you're referencing.
Well, now that you've explained that, like copying a bit of code doesn't even seem like a hassle compared to what you had to do to set all this up.
Yeah, I mean, this was kind of also the reason for the whole static ID thing in the first place, which also like I wanted to avoid that in the beginning, because it's another point of like where it can break, because you're setting this static ID when you're creating the node or when you're duplicating the node. So technically, like you could accidentally evaluate the add-on or like compile the add-on before that thing is set, and then that would break, and that might break the whole like flow, and then it never gets changed, it never gets reset, and like it's the whole thing. So I wanted to avoid it. I couldn't, because we can't do pointer properties to any data type, unfortunately. Yeah, but basically what you need is ref node tree to reference the node tree you want to get a property from, and then ref whatever the ID name of the node that you're referencing is. And then in your display function, so in the draw node function, you want to display first of all the prop search for the node tree. So just in all of the BPY data node groups, we want to search, and because the ref node tree has that poll function, it will only show the node groups that are actually Serpens node groups. And then we have a prop search for the operator node. So the property is this ref, whatever the ID name is that we defined. And then we need to tell it the collection that we want to search in. And this is again the thing which I showed here, like on the node tree. We have these node refs, which is a collection property of all the different types of nodes that you have in your node tree. Of all the different nodes that you have in your node tree. So there's a couple of like utilities for this. The main one you want to use for this is node collection. If I go to the node tree, down here we have the node collection function, which takes in an ID name and returns the self.node ref's ID name, like this collection, this item from the refs collection, which contains all the different nodes of this type. So this means like if you go to the node tree, the node group you have selected, so parent node tree is the node tree you have selected in that property, in that pointer property, and then we go to we call node collection on that with the name of the node we want, and then we get the refs property off of that. So our node refs here have the node ref collection, which then have this refs collection, and this collection contains all of the nodes. So the node references, which do like all of the naming stuff I talked about. So what this does is just giving you a collection of all the operator nodes in the node tree you're specifying here. So this is kind of a lot of stuff happening in the background and not the best interface for it, I think, but it works. And like you have to do a bunch of checks in the UI here. So for we have this parent tree variable which uses the node tree that you have selected in the pointer property if you have one selected. Otherwise it just uses whatever the node tree of this node you're on is right now. Then we're still showing the second prop search, but disabling it if you don't have a node tree selected. So this is like what you see here. Like if you don't have a node tree selected, the second one is grayed out. If you do, then it's shown, and then it will show this for the whatever node tree you have selected there, that collection.
This is great. Like when you don't know much about packages and you open it up and you look at this stuff, it all just seems like mumbo jumbo. But when you explain it, now it just suddenly seems really logical. Like, okay, yep, that makes sense.
Yeah. Right, and the last thing we have like on a bunch of nodes is this like button for finding the node. Like, this is not like really necessary here, but it's you can use this as well. It's just the operator asn find node, and then you give it the node tree you want to search for, and the node you want to the reference to the node or the name of the node you want to find. And then like when you have something selected here, it will just go to there. Same one for this find thing. Like you can, it's just one function, one operator which gets the name of the of this node, and then everything else happens automatically. So you can use those as well. Yeah, I mean that's kind of the basics of references. The other thing you're probably going to use if you have these, well, not definitely, but probably, like the one place you're accessing these properties is of course in the evaluate function. Like you want to know what node you have selected, and then in this case, like draw that. Where's actually that line? There we go. Like you actually want to call this operator then, the one that you have selected, so you get the name from that node. But this also means, like, if I change if I add a property to this node, I still want to update this on my, well, like especially select this one so it shows up. Oh, sorry.
You're on. Keep going.
Oh, okay. Yeah, so if I if I add a property to this, then I want to update the run operator node. And the way you do this is by using another one of the event functions. So we have this onRef update function, which the operator node calls. So if I go to the operator, I have a function called, first of all, I'm using like a bunch of property update functions, which then trigger a reference update. So the operator node knows that there's like nodes referencing it, and it's telling the run operator node like what has changed. So in this case, we're just passing some like data here to this function called trigger ref update. You can also call this without any data, just to trigger an update. But this way, like when this node changes, it will call this function. So it will call onRef update, and with the data if you pass it, and with the node that caused that update. So this means, like in here, when I add a property to this node, I can call this trigger ref update, telling the run operator node that something has changed on that operator node that I'm referencing here. And then I can do whatever I need to do in here. So I can, like in this case, add the same inputs, like matching the properties on this node. I can reevaluate my node here if I need to. And I can do all of that just if the node that's causing, like that has changed, is triggering an update, and if this one is catching that update. Yeah.
Nice. That's cool.
I think this is kind of it about references. I mean, there's a bunch more like utility functions, which I don't honestly all know. Like I look these up when I need them. I've written them at some point, but I don't remember them. So like you have collection on the node, so you can get the collection for the node of this type. So this just gets the one for the node tree that this node is in. There's a bunch on the node tree, like node collection, and as well as connections. Those are not ones you need to use. This is just for like doing the links and the updates and so on. Yeah. Okay.
Nice.
Yeah, I think that's it for references. Any more questions on that or anything else?
I think because like I'd never actually thought to go into like the sockets file and actually look through all the functions and that sort of thing, and like even what you're doing now with like the node tree and all that. Like I never really thought to go in and actually check out the functions.
Mhm.
So just learning that now has already expanded, you know, like what I can find without having to ask you or something. So, yeah, like just seeing you jump through, like, you know, where the functions are being defined
Yeah.
and that sort of thing. That, yeah, that helps immensely just in itself.
Yeah. Like just
Mm.
be aware that like most of these are internal. Like you can access
Yeah.
the current value, but if you set it, then it doesn't necessarily work. Like some of them say that you can override them and so on, but doesn't say for all of them. It's like the code documentation is not perfect. But yeah, like you said, there's a lot of stuff you can just discover from looking through here, like disabling and so on. Yeah.
But for what you've covered so far, like this is pretty much for most use cases of, you know, people learning packages and making some simple nodes.
Yeah.
So like what you've covered so far is really good. I think anything that you cover from here is sort of like going to be more advanced users and that sort of thing anyway.
Maybe we'll do that when you guys get to the level where this is not enough anymore. then I will have to prepare for this because I actually also need to get in the code to remember all of that. But yeah, we'll get there.
One day
Yeah.
we'll be little Serpens, just like Joshua.
Then you take over. Develop.
We'll try.
I'm hoping for that.
I've tried to contribute to Layer Painter.
Yeah, that's
Do whatever it takes. Like I will learn Python for the next 5 years just to figure out how Serpens work. So like just so I can take over if you guys end up losing interest or something. I do
yeah.
not want Serpens to die, man. Like I'm so invested in this add-on.
I'm invested. I have growing responsibilities in my day life, so I love to contribute when I can. But it sucks that my free time is becoming less and less. COVID was nice because I got to be home a lot, but I still try to keep up as much as I can. We're all leaning on you. But I'm definitely not going anywhere. This is the one thing that's taught me how to code finally.
Same.
I didn't know a lick of Python before I started Serpens.
Same. Like it's such a great aid for yeah, just being able to see things in nodes, and then once you get comfortable with, like, you know, understanding a bit of data flow and everything, you start looking at the little bits of code behind it and start understanding some syntax and, you know, how things work and shit. And man, it is such a great aid to learn how to code, I reckon. Like I've learned more from Serpens than I have from looking up anything on the internet or tutorials or any of that sort of thing.
It's connected way more dots than anybody else has been able to help connect, aside from Batfinger on Stack Overflow.
Yeah, for sure.
Posting answers since 2012.
Wow. That's crazy.
Yeah,
Thank you, Joshua.
It's great. It's great to hear that it's helping. Like also at the Planner conference and stuff, just hearing from people, just I don't know, seeing the Serpens name on the badge and being surprised that I exist, and I'm surprised that people know about it. It's really cool. Yeah,
it is.
Are you guys coming next year? I know it's very far.
For Blender conference?
Yeah.
Do we know where it's going to be?
And I guess the main one's still in Amsterdam next year. I think they talked about making it at the same venue.
Oh, okay. I better start planning then.
Yeah, I think I might have to as well. Like, I have honestly not travelled outside of Australia much, but this is something that I would definitely do it for. Definitely.
Yeah,
It'd be a cool holiday.
Make it a longer trip. Amsterdam's nice. Yeah, there was surprisingly a lot of people from like Australia, like for for being like a day-long journey. That's an expensive one. Yeah. Okay. Yeah, I don't know. Maybe I'll see you next year if I have find the time as well. But if they announce it early enough, I'll be there.
That'd be cool.
Yeah, for sure.
Definitely. All right.
Thanks, Joshua. I gotta bounce, and I know it's way late for you, so we really appreciate your
Yeah.
time with us.
Yeah,
This has
it's
been
fine.
awesome.
Yep.
Yeah, no
Thanks
problem.
heaps. Really appreciate it.
No problem. If you have any questions, of course you know the chats. Just ask and I'll help as much
Now,
as I can.
where will you upload the video of this? Is it going to be on your YouTube channel? You're just going to put it in help resources?
I'm actually not sure. I mean, if you want to upload it and just like replace your recorded stream with my recorded video, that's fine with me as well. I don't like it's maybe easier to find for people there, I guess, because there's more Serpens videos there already. But I can also upload it if like I don't really mind.
Yeah, I don't know how many subscribers you have, Corz. I've got 800 plus now. So I'd rather we upload it whoever has the most subscribers, to be honest.
Oh, you for sure. Your
Okay.
channel's way more of a place for info for that sort of thing. So definitely.
Okay. Yeah, if you're not going to upload it to like your public YouTube channel, Joshua, I can upload it. That's fine.
Sure. Yeah, let's see if I can like send over the file and somehow. Yeah, unless the quality is good enough. I don't know if you kept recording.
Yeah, my quality is not great. Things are pixelated, so I'd
Okay,
love to have
yeah,
your copy.
I'll upload it somewhere. All right.
Yep, and also good on your SKD Sam for sticking around and yeah, listening in. You've been
Yeah,
near to the end.
thanks for making packages with us too. It's cool to have people joining the package crusade. Bounce
And
ideas off of.
to all of you, just again, like thanks for just helping out and like when people have questions, it does a lot. Yeah, it's a good help, especially for beginners, like just having people respond. Yeah, so
Good.
thank you for that.
Part of the duty, the responsibility we have to inherit.
I don't know, it's my way of saying thanks too, right?
Yeah, for sure.
I've been in their shoes. We all know what it's like. I don't know what I'm doing. Can somebody please help me?
Yep. And I'd rather people be using Serpens as like a learning tool than getting frustrated with raw Python, because like there really isn't that much for beginners, for coding in Blender, like using Blender Python. You got like a couple of Darkfall tutorials, and I think like there was some videos hosted on the main. Oh, another guy that does coding for Blender, I think. But yeah, there's really not much, and yep, I think if we can get people into Serpens, and we're all acting out like a community and helping people and all that sort of thing, it makes it heaps more inviting. Like where can you go for Python apart from Stack Exchange, and post a question and have immediate response, sort of thing. It's freaking awesome.
Yeah, AI will be the answer.
Yeah, will be the answer. I
AI.
want to do this. Make this happen.
Yeah, for sure.
Yeah, Serpents 50 or something. We get there.
All right,
Thank
I'm
you.
out. Thanks heaps, Joshua. I'll
Yeah.
I'll talk to you later.
Thank you guys. See you.
Yep, thanks. See y'all.